Hello. Hi everyone. Good evening.
Good evening, sir.
Okay. So ready for a session?
Yeah. Yes,
Yes,
sir.
Okay. Nice. So let us start. So I think what we can do. Okay. I think first of all we'll start with the thing that I guess regarding the week wise, or maybe you wanted to see that what is the weightage, right? So maybe I'll just talk with little bit about it. Maybe 2 minutes. Right? So I think is my screen visible to all of you?
Yes.
yes, sir.
Okay, so I'll just maybe talk about a little in a is it okay if I just talk about like lump sum weeks? It's not like week wise,
Yes,
exactly week
yes.
wise. So I'll say that week 1 to 4 maybe. So I'll just divide it in 3 weeks. Week 1 to 4, week 5 to 8, and week 9 to 12. Is that okay? So approximate weightage for week 1 to 4 is very less. Okay, so how less it is? Let us say like
10 to 15%.
uh, yeah,
One
so
question.
like uh, maybe I can say that 5 to 10%, not
10.
more than that. Okay, so you just can see that 10% is. But see, the concepts in week 1, 2, 3, 4, right? So mostly the calculus, how to find. So those you should know, right? How to find the minima, how to differentiation, partial differentiation, finding out the eigenvalues and all those. Because it is again, it's an important thing, right? Throughout
Yes.
the, it's like that is the basic for our entire thing, right? Week 5 to 8, the weightage will be slightly higher. So I can just say that. 30% of the weightage will be from week 5 to 8, and the remaining 60% weightage, right? So I'll say okay, so it's not 30 exactly, it will be around, maybe I'll just say in this format, 25 to 30%, and here it will be slightly around 55 to 60%. Okay, I hope that's clear.
Yes, sir.
Right, so yeah, I think yeah, that's it. So yeah, that's it. Yeah, correct. So that should be it. Any doubts here? So it's this is like maybe I can just maybe I'll just say that it's 25%. Okay, 25%. Just take it as like 10%, and the remaining I'll say that how much it is then 55%. So you can think about like this. Or I'm doing any mistake? 65? 55.
65.
65, right? Yeah.
65.
So more, things will be here, and in that also, if you just need in week 9 to 12, so again, it is so more weightage is so like around inside the 60% also. If I just go to 9, 10, and 11, 12, so 11, 12 will be slightly lower. So how lower it is, I can just say that maybe 25% here, and uh, so yeah, how much remaining here?
Put 40.
40%. Yeah. Okay. So let us talk about it now. So I think this is clear to you, right?
Sir, one quick question. On
Yeah.
week 11 and 12, there are too many formulas there. When we did our stats too, we had a
Yeah.
sheet of formulae provided
Yeah.
during the exam.
Yeah.
Will anything be provided out of week 9 and
Uh,
12 during the
no, no,
exam?
no, no, no. Because see, I think I have already mentioned yesterday. It was a brief, session yesterday, like 15, 20 minutes. I think I had. So I see the questions will be purely based on I can just say that only this concept. Let us say discrete and continuous random variables. In that discrete, you should know what is the distribution of Bernoulli, and I think all of you know, right? Binomial and let us say Poisson and geometric. I think see geometric also. I don't think you should No, but okay. So these four, and here I can just go for exponential, uniform, right? And then the normal. That's it. So I'll guarantee you that these three and these three, right? Out of this six, if you know this six, I think there is no questions outside of it. So for that, you should know what is a PDF and CDF. So again, you just know, or maybe PMF and PDF of these three distributions, right? If you know the PMF and PDF of these three distributions, you know how to find out the CDF. So you don't have to remember all the six things, right?
Yeah.
So that's it. So I think that is from there. And I think, see, then there are things, right? How to find out the values by, so if you have the two independent normal random variables, right? So if I asked you to find out the joint density of it, see, I think you should know it, right? Or if I asked you to find out the transformations of a random variable, we have seen that, I think Sunday or Monday, I think one session had, but okay, we'll look again into it. But that is again that is the concept which we are looking at, right? So week 11 and 12, right? So the concepts will be covered is kind of this one, the transformations of random variable, right? That is basically the important one. I will say that finding out the CDF, right? So finding out CDF, probably like max of anything or minimum of anything or sum of two random variables, right? So it's kind of these three, right? You should work on these three. You know that, right? Z equal to x plus y, Z equal to min of x plus y, Z equals to max of x plus y. Or no, not x plus y, it is xy, right? So how to find out the CDFs of this? Given you already, let us say, given as x is normal and y is possibly, let us say, uniform, right? How to find out that? Those kind of questions you should know. Transformations, I think we have seen. Maybe we'll see again the questions. Yeah, I think those basic things, right? Oh, okay, whenever we look for week 11, 12, I think I'll go through again, right? So all of these things where the questions might come from. I think, see, this is basic, right? This I think all of you know. I don't think for that you need any kind of tables and the formulas provided for, right?
Sir, formulas for stats 2, I mean, if
No.
week 11 and
So-
12 will be provided.
See, I think if you look at through the quiz, right? So I think there will be a section of stats also, right? I don't know.
Yeah, 11 and 12, sir.
No. In whenever you go for exam, will that all the sections will be available for you? No, or is it not like that?
Yes, sir, it is given actually.
So stats 2, in the stats 2, the formulas will be there, right?
Yes,
Yes,
Is
sir.
that correct?
What's the exam? What
All stats are
the
given.
Yeah, I think all the question papers will be there, right? You have to choose your paper, right?
Stats to formula sheet.
but
Oh,
stats
we can check from the stats 2 paper all
Yeah,
the formulas.
Yeah, if you
Okay,
require,
sir.
right?
Logical.
What's the
Yeah.
paper will be in the afternoon?
So I am not sure about it. So
Yeah, that is the issue.
Sir,
No,
how long
but
will
the
the session
thing
go to
is,
be, sir?
no, I see 9 and 12, 9 and 10 will be completed within this 2 hours. Okay, maybe I'll take one more extra hour if you have any doubts. So if somebody don't want to come tomorrow's session, right? Maybe I'll just talk about some PYQs of week 11, 12, whatever. Like the last 1 hour will be a discussion on, and it's up to, like, open to all of you. You can come and ask me the questions. We'll discuss that. Week 9 and 10, I'll be covering in 2 hours. Tomorrow I'll cover again week 11 and 12, right?
Yes, sir.
Tomorrow at same time, sir?
No. I think the timing has changed. It is
It is in the afternoon.
afternoon 12 to 2, right? So it's 12 to 2. Just check your calendars, right?
Yeah, it is 12 to 2.
The PCA question will coming in this session also.
So now you're asking me very specific questions, right? So
No, sir, because the PCA question last time, like 4-5 question came, is
Huh.
actually the one question.
yeah. So the subparts
Total,
will
like,
be there, no?
and
PC.
like other one is the QE QF question came, that also one question.
Okay, but see, I
That's why
think
I'm
your end up,
specifically I'm asking so that, sir, because PC is like long subject, long. It's a
yeah,
full
yeah,
read, so
but
we can skip it if you can tell us like
no,
previous
no, no,
question.
no. See, the thing is, okay, I'll tell you one thing. When you say about quiz one and quiz two, right? I think your time duration for those papers will be 1 hour. Is that right?
Yes, sir.
And the end term will be 1.5 hours. Fine. The number of questions in quiz one and quiz two are like almost similar to the end term. So I don't think so. If you are able to do it in quiz two, I don't think you will not be able to do it. So I don't think I shouldn't give you the answer to this specific question, right? So
So please
whether
go through like constant optimization problems once,
which one?
like week 9
Yes.
and week 10.
Yeah, week 9 and
Yeah,
10.
KBT and all.
yeah.
Just please solve KKT
Convex
questions.
and
There are no
concave
Sure, sure.
also,
KKT.
sir. Some
Yeah,
key
yeah, yeah.
points you control.
Yeah.
Concave and
So
convex.
Let us start with that now. So okay, so I'll just start with that. Maybe so I will not cover everything in a theory. I hope it is fine for you, all of you, because I don't think it's like everything in a theory is important right now, right? So
Yeah.
we
Please
just
solve KKT questions.
more,
They
yeah,
are
yeah,
not
yeah.
there.
Definitely. KKT questions will
more
be
topics which are relevant. I mean, which are
yeah.
important for the entry. We can
Correct.
discuss.
Otherwise, there is no point, right? Otherwise, like if there is no time for us to go through theory. Convexity, all of you know what is a convexity? What is a convex set? Convex set, because these are the important questions. Okay, so the questions might be there to find out whether this is a convex set or not, or whether this is a convex function or not.
Excuse me, sir.
Yeah.
So that
Sir, regarding KKT conditions, I don't think that the proof has been correctly fully mentioned because I didn't get the proof from the lectures. So is it
Not required. Not
not
required.
required, right?
Not required. You just need to know what are the KKT conditions and how to solve the problems. I will show you how to solve the problem.
Okay.
Okay. Yeah. See, the proof I think it's a very longish one, and I don't think it's not needed, right? So because anyway, for quiz purposes, the end thing is important, right? How do you be able to solve the questions? I think that's enough. Okay, so what is a convex set generally? So suppose a set S is there and which is a subset of RD. If it is a convex set, I said, and suppose if I say a set is a subset of, what does this mean by RD? It's a D-dimensional,
Three-dimensional.
right? And I'm saying that S is a convex set, and it is true when if all x1 and x2 belongs to S. What does that mean? So or for all x1 and x2 that belongs to S, right? So then I'll say that convex set when it is lambda x1 plus 1 minus lambda x2,
X2 equals to
right?
1.
When it belongs to S.
Okay.
It's not 1. If it is belongs
Means
to
any
S,
combination
yeah.
of both
And for
belongs to it.
all lambdas which belongs to, so what should be the value of lambda? Basically, if it should be between 0 to 1, right? If it should be between 0 to 1. So it can be, so if lambda is 0.3, what is the value of 1 minus lambda? It is 0.7, right? Definitely. So basically what does that mean is, let us say if you have two data points in a set, let us say x1 and x2, these two data points should be what? They should be on a line, right? Or the line joining these two points should go through these 2 points, right? Without any breakage, right? So if you wanted to find out what is x1, then when x1, if I wanted to find out x1, I can just say that it is let us say lambda equals to 1, right? If I go through this, so lambda should be equal to 1, right? Then I'll get this condition, which is 1x1 plus 1 minus 1 0 x2, and similarly x2 will be what? That for x2, what is the value of lambda?
Lambda 0.
Right? And then if I find out any point here, so if I say that if the point is 0.3 x1 plus 0.7 x2, whether this point belongs to a convex set,
Yes, sir.
right? So this belongs to a convex set, right? Whether this point belongs to a convex set,
No.
No, sir. No.
right?
Sorry.
And
Sir, I have
whether
sorry to
this one,
interrupt you. Hello.
yeah, just tell.
No.
One doubt. So
Yeah.
for the set, I mean for the function to be a convex set, this has to be lambda should be between 0 and 1 only.
Correct.
And as you are saying this formula lambda x1 plus 1 minus lambda x2.
All what are all this? Lambda x1 plus 1 minus lambda x2. What are this? These are all
Lines
the
of
intermediate points, right? They are
Linear
all the
interpolation. Yeah.
intermediate points, right? So these are all the points between this x1 and x2, right? On a line.
Correct. Yeah.
Okay. Okay.
Because if you vary the lambda, see, if you vary the lambda, you will get some point, right? So this is one point, right? Let us say 0.3x1 plus 0.3x2, where it will land. So it will land somewhere here, right? So the weightage of x1 is lesser, and so see this lambda x1 plus 1 minus lambda x2. This is not a so this is, and if I say that lambda is 0 to 1, so it will a series of line, because if I vary 0.1 x1 plus 0.9 x2, right? 0.11 x1 plus 0.89 x2, something like that. So all of these points, and where they will lie on that line joining this x1 and x2. So what is meaning of it is, if the x1 and x2, if these are the points in the convex set, if I'm able to say it is a convex set when all these points, right, between this x1 and x2, they should belong to that set, right? All these points. How many points will be there between x1 and x2?
Infinite.
Infinite. So all those infinite points should belong to that set. If that is possible, right, then I will say that this set is a convex set. Understood? So this is not one point. This is like series of points, because I'm just varying this lambda from 0 to 1, right?
This is constant, right? I mean
Yeah.
lambda will always.
Yeah. Correct.
change.
So for example, if I have these 2 points A and B, right, and if I say that whether this A and B is a convex set or not, what do you feel? Or maybe if I say set is what? Set is a collection of all points, right?
Collection of points,
So if I say that A and B belongs to some set S, can I say that this set contains, or the set which contains A and B is a convex set or not? Definitely, right? Because if I join the line between A and B, right, these 2 points, I know that all these points will belong to that set S. And if can you just say that, let us say this is the set of points. If I say that A, B, C, D are the points of set S, right? If I say that A, B, C, and D, they belongs to set S, and if I ask whether this set is a convex set or not,
No, it's not.
No.
right? Because if I select one point from here, and if I select one point from here, and if I try to join the line between these 2 points, or not all of this, because these points, right, they don't lie either in that interval A, B, and C, D, right?
Okay.
So I hope now you understood what is how to find out whether it is a convex set or not, right?
Yeah. Thank you.
Okay. So there is one more concept. So I'll just skip it a little bit. So maybe the properties and all, if you can just go through it and try to understand. I'll just try to.
Sir, can you solve a question based on this?
Yeah, definitely. Let me complete all like 3-4 concepts, so higher level concepts, and then we'll solve the problems from mock. That's fine, right?
Okay,
give me
sir.
like 5 minutes. 5 minutes, I'll finish off all these concepts. Fine.
Sure, sir.
So there is a concept of convex combinations. Okay. What do you mean by convex combinations again? So so let us say if you have a set S, right, such that it contains some points x1, x2 up to xn, and all of these points belong, they are what? They are a subset of Rd, right? That's okay. What does that mean? I think all of you know, right? What does that mean? X1 belongs to Rd means?
R-dimensional, so D-dimensional. X.
D-dimensional
So D-dimensional.
Real space.
Maybe you can call it as a vector or a point, or in a D-dimensional space, it is a point, right? X1,
Yes.
right? Yeah. So if I say R2,
So it is the matrix like
I can just
having
say that
limits
X1
two
next.
entries. Is that so?
It's a collection of vectors, right? If I say like vectors, or see, if how will you define this X1, this point? Suppose this is if I say that X1 is R2, so X1, X2, X3, these are the points, right? And if I just collect those points in a set, so they will look like this, right? So you can just say them, let us say vectors or whatever, right? So maybe let us say if I denote this as A, then it will be X1, Y1, right? This is B,
Yes.
X2, Y2, right? This is let us say C, X3, Y3. And if I collect all of those points, they will be what? Let us
A,
say
B, C.
Y1, X2, Y2, and X3, Y3, right? Or I will say that instead of writing like this, I'll write like this, right? A, B, and C, and which are the subset of R2. Is that fine?
Yes, sir.
So instead of writing all of this, right? How we are writing it? We are just writing it in this fashion. Fine?
Yes, sir.
Okay, so okay, I'll just rub it out. Yeah, this is RD. Okay, fine. Okay, so if S is a set of all these points, then we'll say that the Z is called as a convex combination. Is also belongs to RD.
Sir,
Yeah.
should this set S be an infinite set?
No, not required, right? It can be a finite set. It is not needed
But
to be infinite.
okay, but you said the condition you gave, according to that there must be line like infinite ones between
No,
X.
this is not the condition. This is the condition to call it as a convex set.
Okay.
What we are trying to say is, if S is a set of 2 points, let us say X1 and X2, can we call this set as a convex set? To check whether this is a convex set or not, what we are doing is we are trying to generate a line between X1 and X2, and we'll try to see that all of these points can belong to that set or not, right? If they belongs to it, then I can just safely say that it is a convex set, right? So basically the points in the set are X1 and X2, right? Okay.
But if there are only 2 points, then it cannot be a convex set, right?
Why not?
Only 2 points, then how it could be a convex set?
Okay, so let us say, okay, so this is a classic example, right? One of the classic examples. So if I say that these are the 2 sets, okay, this I'm calling them as X1 and X2, right? I say that X1 and X2 are the points of set S, right? So can you just tell me whether this set is convex or not? What you will do?
No.
Yeah, what will you do for that to understand? We'll just try to draw a line, and we'll see that whether all the points are in the set or not, right? So it can contain more than these 2 points, right? Because this set can contain all these points, right? But what we are
So
saying
like
is,
we are taking this much points.
yeah, to check whether this is a set or
It is a
like
convex
we don't need all the points, right, in there,
So
right? Like
combinations can be infinite also for any 2
combination
points.
can,
Maybe.
yeah, definitely, right? Because
Okay.
the convex combination is what? Convex combination is basically lambda x1 plus lambda, maybe lambda 1 x1, lambda 2 x2, up to what? Lambda n xn, right? And when this is a combination of, so actually you can see that this is a linear combination, right? The condition over here is the summation of all lambdas, right? And I goes from 1 to
N.
N to 1 to n, and that sum should be equal to 1, and each of this lambda should be greater than or equal to 0. It can be 0, but it should be greater than or equal to 0. So can you tell me how many points will be there in the convex combination? It can be infinite, right?
Infinite.
Yeah, because you can have the like you can see the like lot of you know combinations, right, of this lambda i's which satisfy these two conditions, right, or this z, right? Different conditions you can set up, and then you can say that. So this type of thing, right, z. So this is called as what? Convex combination. And I can, if I wanted to write it in a compact format, how will I write? So if I wanted to write a z, so how will I write? Maybe z is a set. Again, it is a set, right? Set of points in which, let us say, is small z, right? And z equal to what? What should be here? Summation
lambda ix.
I, right? And for some lambda 1 to lambda 1, or maybe I can just say that each of this lambda I greater than equal to 0 and summation of lambda I equal to 1, right? I think that's okay. So this is called as a
Convex
this is,
also?
okay, this is for all, it is a convex combination, right? For all possible convex combinations, we'll call it as a convex hull when convex hull, and it is defined by S for some, right? For some lambda i's which belongs to this. What does that mean? If I have let us say, so you know that, right? Like you should have like if you have 4 points or 4 or more points, right? Or if I have that points in the system, so maybe x1 x2 we are thinking about them as, you know, 2-dimensional data sets. So if you have these 4 points, right, and what are the combinations of these points then? What will be the convex combinations, or whatever are the convex combinations are there? We are going to take all the convex combinations and they should belong to this, right?
This rectangle
Or square, yeah, or maybe whatever. So the shape, so it is like 4 what do you say, 4 sides will be there, right? Yeah.
Yes.
So so where this convex combination should belong to, either they will be on the line, right, joining these two, because okay, if the point is on this line, what will be the convex combination to this? Can be written as
X gamma x1 plus gamma.
lambda
maybe I can say that lambda 1 x1 plus 1
minus
minus
1
lambda
minus
x2,
x2.
right?
plus 0 x3 plus
0
0.
x3 and 0 x4, right? So again, lambda can be anything here, but I think you understand it, right? And if the point is within this rectangle, what will be that case? So it can
All
be
lambdas will be non-zero.
Lambdas.
yeah, so it can be any value, right? Let's say 0.1 x1 0.1 x1 is yeah, I think that's okay, doesn't matter. X2 plus, let us say, 0.4 x3. So what will be the last lambda you should have?
0.2.
0.2 x4, because the sum of all these lambdas should be equal to 1. So this is 0.1 plus 0.3, 0.4 plus 0.4, 0.8, and this has to be 0.2. Yes.
These points have to be form a convex set, or they are just random points?
So what we are saying that this x1 x2 to this x1 x2 and x3 x4, right, or maybe this right, they all belongs to, let us say, convex set. Fine, we are already saying that, and their
We are
convex
already
combination, yeah, then
Is
only
it
we see if
valid for a convex combination?
convex
The
combination
point-
means what?
The combination of all the points, which where the summation of
Which are the
lambda.
yeah, but that is okay, but see, I can just say the combination of the points, right? Why should I say convex combinations?
Okay, because they
Because
belong
they belong to
to
the convex set,
a
right? So
Got
all
it.
these convex combinations, right, of these points, they form a convex hull if this is true. Fine. Okay.
Got
So
it.
can you repeat it, sir? All
So what is the term convex hull?
Convex hull. So
HAL?
convex hull is this one, right? All the points which belongs to this set, right? All the and how can I find out all these points? Through convex combinations, right? Convex combinations means I'll
The
take
linear combinations
linear
such that
combinations. Yeah,
lambdas are greater than
lambdas.
0 and summation
Yeah.
equal to
Greater than.
Right? Is that okay?
Sorry, that term is not clear. Convex, what you said?
Hull, convex hull.
HUL.
HULL.
Okay.
Sir, so all the convex combinations form a convex hull, right?
Yes.
Okay, sir, got it.
See, these are the see, if you have these combinations, right? We already are saying that they are the convex combinations, right? Convex combinations means we already saying that all these points. Somebody is okay. So what we are already saying that this x1, x2 to xn, these all points are what? They are already a part of a convex set, right? What we are trying to do is we are trying to find out the convex combinations of all of this. What is that convex combinations? That z equals to lambda 1 x1 plus lambda 2 x2 up to lambda n xn, where this lambda 1, the summation of all these lambdas, that should be equal to 1, and each of these lambdas has to be greater than or equal to 0. If I know that x1, x2 and xn, they belong to a convex set, right? Then the combinations of those points, if they follow these conditions, right? So you can have any other combination also, right, of these points. So possibly I can have 1x1 plus 2x2, maybe, right? So, or whatever, like any other combination, right? Like 1x1 plus, let us say, yeah, 2x2 plus 0.5x3 plus 0.4x4, right? This is also combination, right? But will this point be a part of convex hull?
No, sir.
No, right? Because it is not satisfying this condition. So all those points which satisfy these conditions, and I think they all belong to either on the line, right? And so line joining all these points and within that hull, right? So those are all.
Does that mean, sir, every convex combination is a part of convex hull?
So it is not true, right? So see, this is also a convex combination, right? Is that, see, if okay, how to say this?
Which combination you are saying?
Okay, so okay, don't worry about it. See, I think that's again, you don't have to worry about like a lot of or maybe discuss about it, right? It's very easy thing, right? So Z is what? Z is called as a convex combination when I say that lambda 1 x1 plus lambda 2 x2 up to lambda n xn, where this x1 x2 to xn, they are what? They are the set of points from a convex set. Is that okay? And
Yes,
they belong to RD, and these are called as the convex combinations, right? Convex combinations. But these convex combinations become or when they will become a convex combinations. So again, so their summation of I equal to 1 to n lambda I, if it is equal to 1, and each of lambda I should be greater than or equal to 0 for every I equal to 1 to n. These are called as the convex combination. Okay. So all these points are called as the convex combinations. Again, you can have so many convex combinations possible, but the convex hull will be that part, right? Where so okay. So when I say that convex hull, that should be, let us say, these 4 points will be there, right? So again I'll just draw. Maybe okay. We'll take a question on this, right? About the convex hull, whether that is a part of a convex hull or not. We'll take about that. So maybe this is x1, x2, x3, and x4. We have to find out these convex combinations such that these things. So what are the convex combinations? V1 to n lambda xi for some values of lambda to lambda n 0 and
Sir,
yeah.
the way we are defining convex combinations, it says that it already includes the condition. So we will not get any like combination which will
Correct.
not meet the
Correct.
convex.
Correct. But for okay, so okay, just find out. So convex hull is what actually is the okay. So the alternate definition of convex hull is that it's a intersection of the all convex sets. Okay, that contains x1, x2 to xn. Maybe we'll okay. Don't worry about it. So when we just discuss about the question, right? Maybe we'll discuss more about it, okay, because I think we are just giving too much of attention to that. We have so many other things, right? So it's better, I think, right?
Yes, sir.
Okay, so there is one more term which is called as a convex function. Okay, so there are how many definitions for convex functions? I think there are 4 definitions. One is, I think, about epigraph, like, right, epigraph of the function. Then there is one definition of like this, right? One is
The
epigraph of f. Okay, why I'm not going through everything, you know that, right? Because I think it's already covered some sense, but and it is not required at this point. So f of, I think, lambda x1 plus 1 minus lambda x2, right? It should be less than or equal to what? Lambda f of x1 plus. So basic definition of what? Convex sets, right?
Yes, sir.
Right, and you might have seen the graph of that also. So maybe I'll just try to draw a graph here again. But again, these are not useful for your finding out, you know, the numerical problems, right? So if, let us say, if you have these 2 points, this is x1 and there is this point. So this is x and this is f of x. So where is this f of x will lie? This is f of x1, right? And this, if this is x2, sorry, this is x. This is f of x2, right? So if I, so what about this? Let us say, what is this? Only this part.
lies between
This is line joining these 2 points, right? Is that correct? When we saw the definition of convex head, so any lambda
The
x1.
second term is equal to this, right?
So, yes, sir. Second term is equal to that.
No,
The
no,
first
only this part. Only this part I'm just talking about. What is
Yes,
this?
yes. Yes, sir. Yes, sir.
Yes, sir.
Only inside that function. I'm just not talking about. So basically, this can be any point, right, over this line.
That on the x-axis, sir. And the x-axis.
Yeah. So okay. So that is, let us say, this point will be somewhere here, right? So this point is lambda x1 plus 1 minus lambda x2, and it can be anywhere, right, between x1 and x2. Sorry, it should be on x-axis. So this point will be there on this line, right? Is that correct?
Yes, sir.
Yes, sir.
Right, and the function of that, or the functional value will be where? Over this line, right?
On that curve, on that curve.
Curve or line?
Function's value will be on the curve, sir.
Curve, sir.
Okay, correct. Yeah, so it will be on the curve. Sorry, yeah, it should be on the curve. Okay, so because if this is the point, it will be on the curve. And what about this part? Lambda
that will be on the line.
Yes, so that should be on the line. So this part is this line, right? The blue color line. So now what the definition says is, if the functional's value of this point, if it is less than or equal to this part, so what is the where is this point belongs to, or where is this point or function's value? It is here somewhere, right? So if you see that this dot, right, this black colored one, so I just say that this is what this is basically
That is greater than the red line.
That is the right hand side.
1 plus 1 minus lambda times, right, f of x2. So right hand side. So if you see, it should be always above. So this right hand side should be always above, or it will be touching to that point, right? It cannot be below or otherwise, right? So when this property satisfies, then we can call this function as convex function, right? Okay, this f is called as the, or this function is called as the convex function. Okay, this is one of the definitions. Third definition is what? The third definition.
Linear combination of linear.
But see, but I think all of these are not much important, because again, you cannot be able to solve this, right? If any function is given to you without a
Linear
graph,
approximation should be less than the function.
yeah. Del of x, right? So this is a linear approximation, right?
Sir,
And that
do
should
we
be.
need to remember these definitions?
No, don't worry about it. These three at least you shouldn't remember,
Okay,
because mostly it will not solve for your thing, right? So okay, just can you just give me a minute? Okay, I think somewhere I'm getting. Okay. So these three definitions are not much important, I think, but it should be like, for understanding purpose, this is these are the definitions are there. There is
sometimes they ask, they give a function and they say whether the function is convex or not.
Yeah,
might need to use some of these definitions too.
So there is the fourth one, right? That will be very important. So that is, I think, useful to find out. So let us say f is twice differentiable, right? Okay.
Yes, sir.
If I say f is twice, what do you mean by twice differentiable? I should be able to find out the second derivative, right? And f is a function of, let us say, Rd to R. In that case, there is one, all of you know Hessian matrix?
Yes, sir.
So what is Hessian matrix? Hessian matrix is basically del 2 f upon
Del x square.
F double x, F xy.
It's a symmetric matrix, right?
Yeah.
Del x del y.
Sir, like
Yeah.
when we have a value 2xy, then will it be splitted into xy and xy? X. So should we split it into xy and xy for the anti-diagonal elements when we are putting it in the Hessian matrix? Like
no, let us say, okay, your question is, let us say if a function is 2xy, you're saying, right?
not function, sir. Yeah, a part of a function. If that value is present after differentiating.
Okay, so let us say
then,
del 2f upon del x square, is it?
Yes, sir. After we differentiate the whole thing, then when we are constructing a Hessian matrix, in del f by del x by del y, will it be splitted into two parts, xy and xy, for the anti-diagonal elements?
No, it will not be like that. So for example, let us say you have a function, right? So suppose you have a function of like this. So let us say I'll take the same example as you're given, right? So x square y, right? What is del 2f upon del x square, or del 2? Sorry, first of all, what is del f by del x?
2x.
2xy.
Okay, so I think we need one more, right? Let us say, okay, x cube y. What is it then?
3x square
Y, right? Okay. Or maybe and del 2f upon del x del y, what is it? I think, okay, again, so for you, I think, okay, let us say this function. This is better. Okay, what is del f by del x now? 2x y square, right? And del 2f upon del x del y is what? 4xy, right?
Yes, sir.
Del f by del y is 2x square y, and del 2f upon del y square is.
Del square at del x del y, how 4x?
So okay,
Oh,
del
that
f,
2y,
okay,
2 into 2, 4.
yeah,
Okay.
right, no?
Yes, sir. Yes.
So del 2f upon del y square will be what here?
4x square.
4x
square.
2x.
No,
No,
2x
square.
square. 2x square.
2x square.
right? Is that fine? Okay. And what about del 2f upon del x square?
2y square.
2
Y square.
right? So Hessian matrix will be now this value, right? I think this value, if you do del f by del y, if I have del f by del y, and then if from here also it will be the same, right? You can just cross check it. It will be same, right? So now h will be what here? 2y square, 4xy, 4xy, and
2x square.
2x square, right? So this is the Hessian matrix. Now I shouldn't split it into 2xy and 2xy, right?
Okay, sir.
Right. So it should be 4xy here.
Sir, this matrix alone can be just up till del x, del y, del
Sorry?
Hessian matrix, sir, and like del f, del x, all those things are clear. But how to put it in this matrix format? There only we are making.
Okay. So what values you need here? So what is the first value here in the Hessian matrix? This value is which one? Del 2f upon del x square. You already found out, and where it is?
All those things are clear. But how to put it in this matrix format?
I don't know. Okay. So from where the
Sir, she's asking the basic formula, like the one that she's asking the.
I don't know. I'm hearing my own voice again. Is that for all of you or?
Someone else mic was on and your voice was echoing from that mic.
Okay, so yeah, please mute somewhere there, and I think. Okay, who's talking now? Just tell me.
Sir, I was asking that.
Hemlata. Yeah. Okay, just tell me what. So this is okay, right? So del 2f upon del x square is which one? Which value? 2y square, right?
Yes, sir. Yes, sir.
So I just directly put it here now. So here I just, it's a matrix, right? Not clear?
Okay, sir. Okay, sir. Okay, sir. Got it, sir. Got it.
So this is kind of like this, right? These are the 4 values. I just have to substitute the values there. I have just substituted here, right? So once you found out the Hessian matrix, then I just have to find out. So when I say that this f is a convex function, f is a convex function when
F of x is greater than 0.
Only if this Hessian matrix H is a
positive semi-definite matrix.
Positive semi-definite matrix. Okay. And when I say this as a positive semi-definite matrix,
eigenvalues.
The determinant is greater than or equal to 0.
So there are 3 things, right? 3 tests. You can use one of these 2 or one of these 3. So eigenvalue test is all the eigenvalues should be
greater than or equal to
0. And the second thing is all the determinants. This is called determinant test, right? All the determinants. Right? All the determinants means you know, right? So for this, how many determinants will be there?
2.
2, right? So this one and the overall, right? So that should be
Greater than or equal to
D1
0.
and D2, so they should be greater than or equal to 0, right? If this
D1
is
should not be 0. D1 should not be 0.
yeah, D1 should be okay.
D1 should be positive.
D1 should be positive and D2 should be, right? Yeah. And there is one more, which is, I think, pivot test. So all the pivots should be positive, right? That is there. But okay, so any one of this, I think these two, if you are able to see any one of it again, maybe you can just go for eigenvalue or the determinant. I hope all of you know how to find out the eigenvalue of a matrix, right? Or 2 cross 2 or 3 cross 3. Mostly it will come as 2 cross 2, right? So
so can H be even positive definite matrix, right?
Yes, sir.
Not
I
so
only-
positive definite matrix will come under the positive semi-definite, right?
Okay, okay.
So
Excluding zero is positive definite.
Yeah. If you have just lambdas, this lambda is greater than 0, that will be your positive definite, right?
Okay, so if there is a statement like if f is a convex function, if and only if H is a positive semi-definite matrix, that means that this satisfies. I mean, it includes the condition positive definite also.
Yeah, you can say that it's like if the it's a subset, right? Positive definite is a subset of positive semi-definite. I can just say in a broader manner, right?
Okay, sir.
Okay.
Got it.
So okay, so I think this is from week 9, I guess, right? All of these are from week 9. There are few properties from week 10. We'll discuss those properties and then we'll see some questions, right? So there are 3 properties about the convex functions.
Sir,
Right?
one quick question.
Yeah, tell me. Yeah.
Sir, a Hessian is positive semi-definite matrix or positive definite matrix?
Hessian is a positive semi-definite. So see, any positive definite matrix, right? It will come under. So if any matrix is positive definite, then again you can say that it's a convex function, right?
Yeah.
If it is a positive semi-definite, then also it's a convex function. So when I say positive semi-definite, what I mean to say that either positive definite or positive semi-definite. What is the difference between
Semi-definite includes positive definite.
Yes. So I can say that, see, instead of saying that all the positive definite matrices, I can say that okay, I don't know, like, see, it will sound weird, right? So positive definite, if I say positive semi-definite, that means positive definite also will include into that. It's a simple thing, right? You can think about like this. It's if this is a positive semi-definiteness, right?
It's a superset and a subset.
This is a positive
Bigger one and
definite.
the smaller one.
Okay. So if in a Venn diagram perspective, I can just say that like this. It is not exactly like this, but we can say that because any positive definite matrix, I can safely say that it is a positive semi-definite matrix. Fine. Any positive definite can be said to be positive semi-definite. Is that okay?
Okay.
Right. Yeah. Okay. So there are few properties. One of the important properties, what you know, right? So I hope all of you know we get concept of gradient descent, right?
Sir, if determinant is 0, then it means one of the eigenvalues is 0.
The whole entire determinant is 0. Yeah, that definitely means that one of the eigenvalues is 0, right? That's correct, right? Because why that is correct? You know the properties of determinant, right? So there are what is the
Multiplication of
trace
eigenvalues.
of the matrix? Trace of the matrix.
Sum of eigenvalues. Sum of the eigenvalues.
Right, and that should be equal to
diagonal
elements. Can I say
diagonal
that?
elements.
But or diagonal elements, or but for what? Like but it's like sum of the diagonal elements, right? For any matrix.
And determinant is the product of the eigenvalues.
And
Product
determinant of matrix is
product
the
of
product. So I can say that, let us say D is a determinant. It's the product of lambda 1, lambda 2, lambda 2, or whatever. So if one of the eigenvalues is 0, right? So let us say lambda 3 is 0, then what will happen to determinant?
Determinant is 0.
So when you have a determinant as 0, then definitely one of the eigenvalues, it can be 1 or it can be 2 eigenvalues to be 0, right? But I can say that one of the eigenvalues can definitely be 0, right? Okay. So again, coming back to the topic, when I say that if any, what is it? Any, okay, sorry. We have studied about the gradient descent, right?
Yes, sir.
Right?
Yes, sir.
So what was that? What is the gradient descent?
Xi equal to xi minus 1.
So all of you know, right? What is the gradient descent algorithm?
Xt plus 1 equal to xt plus 1 equal to xt minus
eta
gradient
learning
gradient
rate.
of
Del f, right?
gradient of yes, del f.
And f is a function. And if in terms of vectors, so when I say this is the scalar value, right? In terms of vectors, so let us say if this xt plus 1 is a vector, scalar. In terms of vectors, how will I write? Xt, this is also a vector, right? Xt also vector. This is scalar, is vector, minus eta
Gradient.
Okay, so I think we sorry, I think I just
in scalar it is yes, it is gradient.
Okay, this is okay.
Sir,
Okay,
this should even be D transpose, right?
sorry.
D transpose, or the difference between.
Yeah, so yeah, that is correct. So I can use the D transpose or I can directly use the gradient of f, right? Is that correct?
Yes, sir.
Okay, so it's okay. So transpose, why we use the transpose thing is because we consider them as vectors, right? So when the vectors come in, we just multiplication happens in a transpose terms, right? The D transpose is actually when we decide, when I think talk about whether this is a good direction or not. I think we talked about the Taylor series, and to prove that whether D transpose of something, right? I think there we have used, I guess, right?
Or I think for a given point, the approximation we have used. So.
Yeah. So currently I don't remember it, but okay, maybe I'll just go through it little bit later. The current point here is why I'm talking about the gradient descent. Important thing is why we use the gradient descent to find the minimum value of the function, right? This function,
Yes, sir.
Right?
Yes, sir.
So f is a function. We use the gradient descent method to find the minimum value of the function, right? That is my goal, right? That is where it is started. So when I say that minimum value of the function, this minimum value, it's a special name, right? So there are two types of minimum values. I think one is local minima and one is global minima. Is that right?
Yes, sir.
So when I so if f is any kind of function, the gradient descent will give me what? If the question is like that, if f is a function, some function, and the gradient descent will give me local minima or a global minima.
Local minima.
Local minima, right? So gradient descent method gives me the local minima. But let us say f is a convex function. Then the gradient descent will give me that local minima, which is
also the global minima.
Right?
Global minima.
So that is a property.
Or local minima, convex function.
Yeah. So it's a basically gradient descent algorithm tries to find out the local minima, but in case of a convex function, that local minima is a global minima. Why that is true? Because convex functions will have only one minimum value, right?
Yes.
That's correct, right? That is why the property comes into the picture. So in case, so if I know in prior, if the function is a convex function, then I can say that if I go through the gradient descent algorithm or any other algorithm, the value I'll get, right? The value of the function will get, the minimum value of the function will we get, that is a global minimum value. Is that right? That is one of the properties. I hope this is clear to you. And how to find,
Yes,
how to
sir.
say that it's a convex function?
By the Hessian matrix.
Hessian matrix.
Yeah, Hessian matrix or any other, any one of the three definitions, right? So basically when we deal about the mathematics, I think this is a better one, right? So Hessian matrix. So if the Hessian matrix is positive, semi-definite, then we'll say that
it's a convex.
This is a convex function.
Right, no? I hope that's fine. It's correct?
Yes, sir.
Okay. So yeah, so that's the
One doubt.
Yes.
So all the positive semi-definite matrix form a convex function, sir?
okay, I don't know. The reverse is converse is true or not, I'm not sure about. All the positive semi-definite matrices, you're saying that it's convex or not, right?
Yes, sir.
Okay, think about it like, okay, we'll have some kind of quadratic function, right? I think that quadratic functions okay, think.
Simple x square, sir.
Yeah, I think it no some
is
of the
perfect, sir.
it will be true for all the values or not, that we have to think about, right?
Sir,
I think yes, the converse should be true, right? Because see, we have that part, right? How to there is one more definition of the positive semi-definiteness or definiteness is what? X transpose AX is greater than or equal to 0, right? And this gives me a polynomial, right? Sometimes it's a quadratic equation, but from that quadratic equation we'll be able to find out the matrix A, right? All of you, I hope all of you know this part. How can I find out the matrix A from the quadratic equation? You know?
Yes, sir. Yes, sir.
Yes.
We have to separate the variables and then try to.
To find the roots of it, characteristics.
So what will be the, can you just tell me what is A here?
1, 2, 2, 1.
1. So the coefficient of x square is here, coefficient of y square will be here, and this is right, this is actually 2 times 2xy, right? This 2 will be here. So if you just try to multiply this, right, 1 2 2 1, what is x transpose? xy and xy here, right? So if you just multiply, so I'm just xy x plus 2y, that is 2x plus y, and the final will be x square plus 2
xy.
Okay, sorry.
xy.
2xy plus 2xy plus
Plus
y square. So that will be x square plus 4xy plus y square. So if I give you this, you will be able to find out this, right?
Yes.
Yes, sir.
And from there, so now I can say that this x square plus 4xy plus y square for all the values of x and y, this is going to be true, right? This which thing? This thing. It will always give me greater than or equal to 0. Why? Because this is nothing but x plus y to the whole square, right?
Yes, sir.
Is it correct, or x plus y to
No,
the whole
sir.
square, or no, right? So
Correct. A square plus b square. Correct.
plus, but it is 4xy here,
No,
right?
no, no. Yes.
Plus 2xy also.
Okay, so okay, but what does I wanted to say is, let us say if this will be like this, in that case, okay, then this will become 1 1 1 1, right? Okay. Or maybe if I wanted to change it to 3 and 1 here, so this equation will become what? 3x square. But then again, it will be not correct, right? Then you should have, if I wanted it to be positive definite, okay, I'm just trying to get it positive definite. In that case, what should be here? The value here?
2, 2.
Not 2, not 2. 3x square, right? So 3x square. So this should be 3x plus y to the whole square if I wanted, or, okay.
We would require 6xy, no, sir.
3x plus y the whole square is 6. In the middle term, it should be.
I think this is okay, right? So 3x square plus 2xy plus y square. Now I can write this equation as 2x square separately, right? Plus x square plus 2xy plus y square. No, I'll tell you why. So this 2x square plus this will be a quadrant. This will be now perfect square, right?
X plus y the whole square.
X plus y to the whole square. Now, for all values of x and y, can this equation
be positive?
Positive,
Greater than
right?
or equal to 0.
Yeah. So in this case, what will be the matrix? The matrix A will be this, right?
3, 1, 1.
3, 1, 1, 1, right? Now, this matrix A is a positive
definite,
semi-definite, or maybe okay, definite or whatever. So positive definite and positive semi-definite, I can just say the same, right? Okay. Okay, but
How is this correct, sir?
Sir, how it is correct? 3, 1, 1.
because see, for all values of x, right now,
Sir, like 3x square na top 3, y square coefficient 1, so diagonal second 1. 2x5 means if we multiply 1 into 1, we get only 1.
what is the
We
problem?
multiply or add?
Yeah, I think.
No, what I so where is the problem? I don't understand. Where is the problem?
Actually, sir, the anti-diagonal elements, you wrote 1 and 1. And you wrote xy plus xy. I mean, 2xy plus 2xy in the before step. So we were thinking, how did you write that?
Okay.
Now it is clear. You just added the. So now, when you erase the previous step, now I think it.
Okay. So no, I was just playing around, right? Because I wanted some example. I don't have any example with me actually. I'm just trying to create one example. Okay. So now you just see that it's like, okay, 3x plus y. Okay, I'll write it clearly now. So if this is 3x plus y, right? And this is what? X plus y. Now the final will be what? 3x square plus xy plus xy plus y square, which is basically this one, right? This term. Now, if I have given this term directly, right? And I said that x transpose ax is equal to 3x square plus 2xy plus y square. And if I ask to find out what is the A, can you directly tell me what is A?
It's a 3, 1, 1, 3, 1.
So 3, the coefficient of x square will be here. The coefficient of y square will be on the diagonal side again. The coefficient of this, right? Basically, we have to split it, right? So 2xy, I have to split it here to be 1 and 1 on that side. And that is exactly equal to this. So if I...
This only, sir. Split means should be split as sum 1 plus 1.
No. So for example, if I have the value in middle value as 4xy, right? In that case, what should I have to do?
2.
Right?
Means half of the
Equal by
coefficient.
2.
Yeah.
By 2.
2.
We are finding by 2. 4 by 2, 1 by 2.
Yes,
like
yeah. Right?
Okay.
So
Now
currently,
it should be 1,
yeah.
1.
So
Even if we add, it will be the same thing, right, sir? Even if we divide or even if we add.
okay. So see, you are okay. That's correct. You do whatever. So it's divide, add is fine, right? That's okay. It's basically, see, if you divide things by 2 and if you add it like half, right? So I think it's the same thing, right? Half plus half is equal to 1, or 1 by 2 is half only, right? So that's okay. The important point to discuss here is, if this matrix A, if this is a Hessian matrix, right? And if you get the values like this, that means if you know that it's a positive semi-definite or a positive definite matrix, right? Then can I say that, I think what was the question? Can I say that
if it is a convex function
or not? And this is going to be a function, right? Is that correct?
Yes, sir.
See, because suppose if I have given this function 3x square plus 2 xy plus y square, and if what will be the Hessian matrix of that? Again, that is my question again. So can you tell me what is the question? So what is the Hessian matrix here?
3, 1, 1.
3, 1, 1, 1, and that is basically this one, right? And now this is a positive semi-definite matrix, right?
Yes.
And if it is a positive semi-definite matrix, what does that mean? That's a convex function. Right? So I think the converse is true. That was my point to say that, right? Okay. So if a function is convex, in that case, can I say that the minimum value which I am getting is a global minimum or a the local minimum can be considered to be as global minimum, right? Yeah. Okay. There are certain more properties which are important. So,
sir, one doubt is there, sir. In the previous slide, just goes one time. So, like, this is not a Hessian matrix, na? Hessian matrix is like in the first 1 into 1
what
place.
is del x by del x?
Del x by del x is like 6x plus
2y.
2y, na? And now we square it.
Okay.
It will be 6.
So it will be different, right?
It is like other matrix actually.
Okay. It shouldn't be the same, right? Okay. This is 6, and then here it will be with respect to y. That means it's 2. Here
also same.
2,
it is
and
1.
Here 1. Okay. In this case, is it 1 or 2y plus? Okay.
No.
2y.
I mean, when we split it, it is not.
It's 2, right?
Not 1, 2.
2, right? See, del f by del y is
2, yes, sir.
2, right? Sorry, del f by del y is 2x plus 2y, and del 2f by del y square is 2. So again, if I take 2 common,
okay, fine, sir.
3, 1, 1, 1, right?
Yes.
So it's going to be right. So it's around there, right? I think, see, it's my observations, whatever we have learned, right? I think through my observations, I think if the Hessian matrix is the positive definite matrix, right?
Yes.
Then definitely it is convex function. We know that. But I think if a function is, I don't know. That was a question, right? I just forgot. And if a function is convex, then definitely
So the inverse is also you prove.
Yeah, so converse, right? So yeah, okay, I lost the track in between. Okay, so,
yes, sir.
Sorry.
So we can do this way now. Also, we are given some equation. We can
yes.
Do Hessian matrix, right?
Yeah. So I just tried to check it. Okay, so that's it.
Sir, one small doubt. Like a function is given, so if we double differentiate it, and if we get a positive value, will it mean that it is a convex function? I've read this property somewhere.
Okay, so if the value is positive, what does it? So what is our important thing about? So what is the definition of positive definiteness or positive semi-definiteness? One of the properties, x transpose Ax should be greater than equal to 0, right? Or you are saying that determinant, right? You're talking about
No, I'm talking about the function, sir. If it is positive, like when we double differentiate it, when we double differentiate it, and if the term, if the value
terms
is
will be like this, right? These are all positive values, right? Is it?
Okay. I meant to say was if there was a single variable, 3x square or something, and if we double differentiate it, if the value is positive, will it is?
Yeah. That is correct. So that is for single variables, I think it's very clear, right? I think for single variables, how will you find out the minima? So if you have a function like this, whatever function you wanted to say, take. So suppose 3x square, right? Whether this is a positive, whether can I say this is a convex function or not? What you should do? Del f by del x is 6x.
X and then 6.
And del 2f by del x square is 6, which is greater than 0. That means the value of x has to be minimum. Now, what is the value for to be minimum? So x equal to 0 is the minimum value, and definitely it is a global minimum, right? There is, see, for single variables, I don't think there is any other alternative, right? Because it's a single variable, correct? So in single variable case, it's very clear to you. You just draw a graph. You can be able to draw a graph, right? So this will be your x, and what is this? F of x, right? You draw a graph now. This is definitely a convex function, right? Again, you have the graph like this. Is it a convex function or not?
No.
But
No, sir.
no, right? So if that is not a convex function, then again, if not convex function, then if I use the gradient descent algorithm, so if I start with here, maybe I'll end up here, right? Or if I start with here, I'll end up with here. I cannot be able to say that whether that is a global minima or local minima. Is that correct?
Yes.
And okay, suppose what kind of graph this looks like? Let us say f is x cube, right? In that case, del f by del x is 3x square. Del 2 by del x square is
6x.
What I have to do to check whether this will give me minima or maxima? I have to equate it to 0, right? I have to find out the critical points. What are the critical points? 0. One critical point again. And I have to put it back here, right? Or no?
Yes, sir, that derivative will be 0 now, second derivative.
Second derivative is 0, and in that case, what we should
It's a saddle point.
whether this is a minima or maxima or what? Saddle point, right? So because this x cube will look like this, I guess, something like that, right? And somewhere here it will. So at x equal to 0, why that is called saddle point? One side the function is increasing, and other side of that function, that point, the function is decreasing. So in case of a single variable, you have 3 definitions. So in that case, your double derivative, if it is greater than 0, in that case, the function is having minima, right? If the second derivative is less than 0, your function is having maxima, and if it is equal to 0, then it will have a saddle point.
But
Okay?
sir, here it is 6x del square f.
No, you have to put it back, right? So at what point you have to check, no? So you will get that point. So first step actually was this. This is okay. This is the first step, right? Is a function. So normally what you do is you first of all find out the critical points, and how to find out the critical points? By equating that function, differentiation, the first derivative to 0. So here you will get this is as a critical point. Now we'll check for that critical point only. We are not going to check for other points, right? Because I have got this critical point. Now for this point, I have to check whether the function is having a maxima or minima. Then what I have to do? I have to find out. So now I have to substitute it here. In case of x square, what happened? I'll tell you. So if you have f as x square, then del f by del x is what?
2x.
Then I have to again equate it to 0. I have to find a critical point here also. So what is the critical point? 0, right? Now the second step is I have to find the second differentiation. And what is that? 2. Now again I have to substitute here, but this value, right? It is free of x. So I cannot substitute there, right? So now I am just getting a constant, right? So now I have to check whether that constant is
Greater than 0.
Yeah. So let us say there is this case. What is it here now?
4x cube.
4x cube. Just final, just 2 minutes. So this under the second derivative is
12x square.
now substitute there, right? So and then we have to decide whether. So again, it will give.
Then
me
it is
0.
a saddle point, sir.
Again, yes.
So these things we already study, sir. Please.
Yeah. So I'm just because I know some of you know, some of might not know, right? So yeah. Fine. Okay. So there are few properties. I'll just talk about the properties. So one property, right? The first property is if f of x, right, which is, let us say f is a function from Rd to R, and there is a g which is a function of let us say that is also from Rd to R. If both of them are convex functions, right? If f and g are both convex functions, then the sum of those functions, right? F of x, g of x, it is what?
Convex.
It is convex. So if both of your functions are convex, then the sum of those convex sum of those functions will always be convex, right? This is always true. Okay. There is another property which is called as composition, right? So what is composition? Compositions.
FOG.
FOG, right? So f is let us say from R to R is, let us say, it's a convex function and non-decreasing function. Okay. These things you have to remember. Okay, so this is a non-decreasing function. In that case, and there is one more function g, right? So g is
Convex
G to R. If that is a convex function, in that case, the composition of those functions. What is composition?
FOG.
FOG.
FOG. And basically, what does that mean?
F of g of x.
F of
X, right? So basically, you have to put the values into that, right? So whatever g of x values are there. That function will be what then?
Convex function.
That will be a convex function, right? But this has to be true. Your f has to be convex and non-decreasing. If that is convex and if it is so if it is decreasing function and g is convex function, then it will not be true, right? This true has to be true. Okay.
So non-decreasing, if it is not present in F, then
then we cannot say it might be or it might not be.
Because how? I mean, any reason for that, or
No, I think these are all the properties which are like found out, right? So
standard properties.
yeah, so it's not like so there is a proof. I think sir has given the proof about the why it is not. You can just look at that if you need it. Okay? But for so this is like, this session is for only quiz point of view, so I'm not just going into all the details.
Yes.
Yeah?
Okay.
Okay.
Yes.
So there is a function, let's say f R to R, if it is a convex function, and let us say g, which is R d to R, if it is linear, right? See, so about g, you have to understand. They are just saying that g is a function which is linear. It need not be convex or any kind of thing, right? Then the composition of that f of g. So there are two type of compositions available, right? Is this a combination? This also is a combination, right? So this is not true. Only f of g. So in that case, you have to understand this part also. Okay, otherwise, you will not get the correct answer. So f of g will be
convex.
Convex. So we'll just go through it once more. So if you have both the functions as convex functions, f and g, then the sum will be convex always, right? Okay. If both of the functions are convex, then the sum will be convex. If one of the functions, let us say f, if it is convex and non-decreasing, and another function is convex, then the composition f of g is convex. Okay. The third property is
G of f cannot be convex.
cannot, yeah, may or may
And-
not be. We cannot
Okay.
say about that.
Okay.
If f is convex and g is linear, then the composition f of g is convex. Okay. Okay.
So non-decreasing is nothing but it is always positive when we differentiate it, right?
Increasing,
non-decreasing, yeah, that's correct.
monotonically increase.
Yes.
Is it double differentiation? Like should it be positive or only?
No, single differentiation is okay, right? Why we have to go for double differentiation?
Okay, sir. And for linear, it's just there are no degree for the variables, right? As in it
Linear-
is just plus y.
Yeah. The what is it? What is it called? The
Straight
exponent,
line.
right? Oh yeah, the straight line is correct, but the exponent, or I can say the degree.
Degree
of
one
random
polynomial.
is 1, right? In general, okay, so if f and g are convex, then okay, so there is one example sir has given, so I'll just take that same example to get it better understanding. So g of x is x square. Is it a convex function?
Yes, sir.
Yes.
Yeah. Yes or no? Yes, right?
Yes. Yes.
Yes.
Okay. No, yes. Okay. So why it is convex? So, okay, what is the first differentiation?
2x.
2x.
And the second differentiation?
2.
2, right? So, so if it is positive, right? If you are getting it positive, then you can say that it's convex function, right? Okay. And why? Because this is greater than or equal to 0. What does it mean? It's a minima, right?
Minima. Local
and,
minima.
and actually it's a global minima, right?
Yes, sir.
It's a convex
Global.
function.
Yes.
So
Achha,
there
it is
is
a convex function. That's
right.
why global.
Yeah. And f of x is e to the power minus x. Is that a convex function?
It's a
It's a
concave function.
convex. It's a convex function, but it is decreasing function.
Convex but decreasing,
increasing.
right?
It is a convex, but it is decreasing function.
Yeah. What is the graph of it? Let us say if I try to draw a graph, what is the graph of it?
It will
right?
yes.
Okay.
So yes, sir.
Is that fine? This is e to the power minus x. Actually, it's a convex function, but it's a decreasing function. So x square is it's convex. Sorry, f of x. Sorry, g of x is convex, and this is convex.
Sir, without knowing the graph, how can we say that it is decreasing?
We have this, no?
So x square is
Why?
not
Decreasing?
How can we say?
It's, see, if what is
Find the gradient. Find the gradient.
You can find a gradient, or you can just simply put the values right there. What is the gradient in this case? Let us say. Can you just tell me what
Minus
is
e raised to minus x.
Minus e power minus x.
right? No, so that is f dash of x, right?
Minus e power minus.
Which is always negative.
So
This is always negative.
For any value of x, what is the
Okay, so yeah, got it.
But sir, above function x square is not always positive. Sorry, a slope is negative sometime also. I mean, it is not increasing always.
It's okay, but that is a convex function, right? We have one property. What is this property? If f is convex and non-decreasing, right, and g is convex. So suppose I am just saying that g is convex, right? F of x is convex, but it is decreasing. So I think some of you have
This
asked
will not be a
the composition of it
will not be convex.
right. So f of g, right? So f of g will be what now?
F of
e
g
raised to minus x square.
That is
E
basically
raised
f
to
of
minus
g of x. F is
e raised to power minus
f of x square. So I have to just e to the power minus x square.
X square.
That is f of g. Now whether this e to the power minus x square is convex or not, how will you decide?
double differentiation.
So I'm saying that it is h. So del h by
del x.
Okay, basically, sorry, it should be del dh by dx, right?
Okay.
Single variable. It's not a partial differentiation, right? So I think I have made the mistakes above also, but it's okay. dh by dx is
minus 2x e raised to power
minus 2x
minus 2x.
Is that correct?
That's same thing.
minus 2x e raised to power minus x square.
This is correct?
Yes, sir.
Yes, sir.
Yes, sir, it's correct.
Now what I have to
E
do?
raised to power minus x square, sir. E raised to power minus x raised to minus 2 you have written.
X square, Then
Maybe
Then
Double differentiated.
shall I have to find out this thing or directly double differentiation? Okay, tell me.
So minus
2x
x
again
into
minus 2x e to the power minus x square
plus
plus
minus 2
or maybe minus 2 e to the power minus x square, right?
minus x square. Yeah.
So finally it is something like this, right? Like 4x square e to the power minus x square minus 2 e to the power minus x square, right?
Yes.
Okay,
Yeah.
so now next, how can I say that whether this is convex, concave, whatever?
So we have finally 4x square minus 2 into e raised to power minus x square. Now e raised to power minus ex square is we have to know. Okay.
Okay.
And this part is positive. Second part is positive always.
So it is a convex.
It's not positive for below 1 by 4, 1 by 2.
First, you have to find the
Critical points. I told you.
critical
Right?
part.
So that
So x equal to 0 is a critical. X is equal to 0 is a critical point.
So basically, e to the power of minus x square equal to 0. This minus x square is ln of 0. What is ln of 0?
It is not defined, sir.
Not defined, right?
ln of 0.
So what are the values of x square?
No, we have to put e raised to power 0, which is 1, and it is minus 2 actually. Whole equation will be minus 2 when we put x equal to 0.
Oh, okay. So yeah. So what will be the value of x? X can be equal to 0.
X equal to 0.
For that, sorry, x equal to 0.
And for x equal to 0, the double differentiation will always be negative.
So so here if I put x equal to 0, so this is a critical point, right? And here if I put it e to the power 0, which is 1, 4 into 0 minus 2. So this
will always be negative.
Negative,
Minus
and that means what? It's negative, and hence it's a maxima. That means it's a concave function.
Not is concave function.
If it is a concave function, so what does that mean? If my g of x is convex and f of x is convex and decreasing, then in that case it might be convex or it may not be convex, right? But
No, sir, the properties, it should not be decreasing, na? Convex and not decreasing.
yeah. So in that case, definitely it is convex. This is always.
Definitely.
Right? Okay. Always my f of g, convex and non-decreasing and convex, that combination, it is always convex. In this case, now we have seen this example, right? Convex and decreasing. In that case, this time I got concave. But it can be possible that I will have a convex function of this kind.
Okay.
So it may or may not be. Understand?
Yes.
Okay. So let us solve some problems over this, and then we'll see the KKT conditions. Okay. This is all the most of the topics from week 9 and 10, and I think one more left is KKT.
Yes, sir.
Okay, so let us solve some. I think this is very basics, right? That maybe we'll solve it tomorrow. We'll just solve the questions from 9 and 10. Okay, the question number 6. If this is a function, right? Question 6. I'm just going to solve question 6. 2x square plus 2xy plus y square, right? So f of xy is 2x square.
It's basically x plus y to the whole square.
Yeah.
No, sir.
No, it is not right.
X square plus x plus y the whole square.
And the point, so this function is given to me, and the question is for 0, 0, so this is a critical point they have found out, right? Or okay, so this is the point they have found out 0, 0. At that point, whether this function will have maxima, minima, or saddle point. How to find it out? No, okay, that is okay. How to find it out?
First of all,
Double
find that.
differentiate and double differentiate and find the Hessian.
First of all, find out the
critical point.
We have to find out the Hessian matrix first, right? So Hessian matrix is
2, 2, 2, 1.
2, 1, 1, 1.
2, 2.
Okay. So right. So this is the Hessian matrix, and I'll just
4, 2, 2, 1.
So it is first is
4x.
let us say del f by del x is 4x plus
2y.
2y, and del 2f upon del x square is
4.
4. So this is 4 here. For del 2f upon del x del y is 2.
4x.
So this is 2. Now I have to find del f upon del y, which is 2x plus 2y. And del 2f upon del y square is 2. Right? And at 0, 0. Right? So at 0, 0. Where should I add this 0? No, right?
Sir, can we just get this matrix directly from that equation like you showed earlier?
See, I think, there you have seen that part where you got like 2 outside. We have to take a 2 outside.
Yeah, got it.
So that shouldn't get the confusion, right? So it's better to follow the. I think it will not take much time, right? So it's
Okay.
right, yeah.
But
So,
I guess the positive definite or semi-definite we can just determine using that also.
Yes. So here you can just it's very easy, right? So you just have to take out x square common, and here it is basically x plus y to the whole square, if you can just understand it here. For all values of x and y, so now at 0, 0, if I put it there, it's going to be 0, right? So it's a positive semi-definite.
Yeah.
This is positive semi-definite, but that's, see, again, you don't have to do it, all these things, right? It's better to follow okay. So it is what? So I cannot put it 0 because all of these terms are free from x and y. So basically, this is the Hessian matrix. What I have to do now?
Hidden values or determinant?
Determinant. So let us say determinant
Greater than 0.
Determinant,
8 minus
determinant is 4, and the second one is 8 minus 4.
Is greater than 0.
So this is definitely positive.
Semi-definite.
And then I can say that the function f is
Convex.
okay. Again, okay, sorry. The question is, if it is convex function, then definitely you'll get a minima. If the question in this part, if it was the option of local minima and global minima, what would you have done? Like
global minima.
Actually, both, right? So
both.
Okay. Seventh question: are you able to see directly and tell me whether it is positive definite, semi-definite?
Positive definite and positive semi-definite both.
Positive definite and positive. Okay.
A and B.
Okay, that you can just right. So it's a diagonal matrix, and I can understand what is the determinant of this matrix. It's like you don't have to calculate.
Product of the values. 35 into 9.
Yeah, 5 into 7 into 9. Right? All of you are okay with that part because it's and what are the eigenvalues?
5, 7, 9.
5, 7, 9.
5, 7, 9, and all are positive.
Positive, yeah.
Okay. Shall I solve this one? Gradient descent one? This problem?
Yes,
Okay.
sir. Yes.
Let us solve this one. This is from VKETA. Okay. So what is this function? So f of x is x square cos x.
Sir,
Yeah.
similarly, we can say that if it is a negative definite, the semi-definite, then it is also negative definite.
Yes. Yeah, that's true.
Okay.
Initial point is
6.
X naught is given to be 6, and eta, the learning rate is How much? 0.25. Okay. And how many iterations are given to me? No, what are okay. So we have to find out the first point and the second point. Okay. So x1 will be what? X1 is first of all, okay.
X0. Find the gradient first.
X0 minus eta f dash of x. Right?
Yes.
So first of all, I have to find or f dash of x0. Right? Sorry. The proper thing is x0. Okay. F dash of x I have to find. What is the f dash of x? Basically, it is 1 by 10 x square into sin x minus sin x plus 2x cos x minus 1.
Yeah.
Right. Okay. So x1 I have to find. What is x0? 6 minus the learning rate is 0.25. F dash of 6. Now the
cos x, sir? X square. Okay. Sorry, I copied it. Sorry.
Okay. So f dash of 6 here, right? So whether this 6 is now, you have to be careful here because sin x and cos x are here. So whether this 6 is in degrees or in radian.
Radians.
So
Radians.
Radian, I think we have to
So x is 6 radian, right? Okay. How to convert that into the degrees? You know it?
By 2 pi.
120 by into 180 by 2 pi.
6 into 180 by 2.
Sorry,
Right?
pi maybe.
Sorry, pi by 1.
Pi.
No, that is correct. No?
pi by 180.
I think, yeah. No, not pi by 180. I think it is
180 by pi.
Is it 6
You're
by
sure?
360, sir?
But sir, we have to calculate using calculator, right? So we have to take radian, right?
See, if you can't, oh yeah, sorry. If you wanted, you cannot be doing it in the degrees, right? So yeah, sorry. So it's basically, so basically it has to be in a degree. So okay, I'll just find it out. 6 because this is sorry, not degree, radians. So here is 6 radian. So 1 by 6 into 0.25 and f dash of 6 is basically. So I'll just find out here separately. It is minus 36 sine of 6.
6
plus
12.
2 into 6 is 12 into cos
of 6 minus 1.
I think in the calculator which is provided to you, the radian is already there. So you need not to convert it into the degrees, right? You can convert and find it out again, but it should give the same values, right?
We don't convert it into degree in the
don't need no need, right? So unless it is specifically told to you that these are the degrees, right? Here, since the value of x is given to be 6, that means it is not in the degrees. It's in the radians, right? So you just, I don't know what is the value of it. If somebody has already calculated this, tell me. Otherwise, I'll just put it here.
Sir, I'm getting the answer as 5.48.
Total.
Total, yeah, full.
So f dash of 6 is this one. So x1 is 5.48.
46.
Okay.
46 or 48.
F dash C?
F dash of 6, not C. Sorry.
Sorry. F dash 6.
6 is this one.
What's the value of that?
I don't know. You have to calculate.
We have to.
This is in the radian, right?
Sir, we will get the range, right?
Yeah. And x2 will be now, let us say 5.46 minus 0.25 into f dash of 5.46. So basically here your f dash of 5.46 will be what? 5.46 square
minus
into sine of 5.46 plus
2 into 5.46
cos of 5.46 minus 1. Is that okay? And whatever the value of this will come, you have to put it here and you have to find out the final value.
I am getting 4.77.
Okay.
But as per 5.48.
It's okay. It's okay. It's like somewhere nearby. So on. Right? Okay.
In f dash of 6, divide the whole expression by 10.
Okay.
I think you left.
by 10. I think here also it is needed, right? So by 10. Okay. Okay. I think this is okay, right? This is fine.
Yes, sir.
Right. So next one, KKT conditions, I'll just talk about it after some time. This one maybe I'll talk it tomorrow. Okay, okay. These are the questions, all questions from. What about this 18th? What is the boundary value of y so that the function f of xy remains convex? What does that mean here? So when this function will be convex?
When the double differential Hessian matrix is positive, definite, semi-definite.
Semi-definite, right? So what is my function here?
X minus 7 whole square plus
What?
y plus 9 whole square maybe. Y plus
9.
3, right?
Whole square. So Hessian matrix of this will be what then? Okay, first maybe I'll just instead of writing out this, what is del f by del f
2 into x minus 7. 2
into
x
x minus 7. Okay, del 2f upon del x
2
square.
into y plus 9.
2
Del x
into
square.
y plus 9.
2.
2, yes.
And del f upon del y is 2 into y plus 9.
Y plus 9.
And del 2f upon del y square is 2. And from any one of these, I can just find out del 2f upon del x into
0,
del y,
0.
which is
0, 0. 0.
0, right? So Hessian matrix will be
2, 0, 0, 2.
0, 0, 2. And can you just tell me, like, because here
positive
lambda
semi-definite
is 2, lambda 2 is 2, so both of the eigenvalues are
same also
positive, positive, and if they are positive, definitely that means it is positive semi-definite. And that is mean by it's convex. Already it's convex.
Always convex. Always convex.
So will that this function, right?
It is independent of y value of y.
Yeah. So it will remain convex for any value of y, right?
Yes.
Because
Sir, any value of y, how, sir?
Because this Hessian matrix, right? Is it a is it dependent on y? Any like?
No. Okay.
No, right. So definitely anyway. And one more thing to understand here is this function. If you look at this function, right?
It's a circle with a center at 7 and minus 9.
Yeah, and one more thing, like it's a square, right? Y plus 9. So any value of y, it's already giving me the positive value for any value of. So okay, I think because this if I try to find out the x transpose a h, right? So hx, that will give me what it will again give me that bowl kind of shape, right? And that is going to be positive. So basically, okay, you can just understand it from here. It's going to be a
circle, sir. It's a circle. It's center at 7 and minus 9.
Yes, sir. Circle. 7 and minus 9 is the center point.
Center.
Okay. And
the radius is the.
But the
radius is what is we want to find. So radius will always be positive.
So radius can be anything, right? So radius is.
Circle is a convex figure, sir.
Yeah. So like if you can plot it in 3D, then we
basically
will get...
circle is
convex, right? Because if I take any 2 points from this, if I try to join a line, I think that will give me a convex. Right. So okay, I hope that's fine. And basically, this will be a 3D graph. It's not going to be a because.
So wouldn't it be a cone in 3D?
Cone, I will not say. I guess this can be like this, right? So let us suppose I'll try to show you. Possibly it's a cylinder, right? So it is x.
But sir, its radius varies, no? The value
3D means there are x and y, na?
So this is kind of thing, right? I'm not sure, like whether it's 7 minus 9. So I don't know. Somewhere, I think 7 minus 9 will come that side, right?
Anyway, sir.
Okay. So is it correct here somewhere? And now the function's value will be what?
So it can be anything. Radius can
Right.
be anything also. It can be any circle.
Radius can be changing again, right? I don't know about the radius, but the function value will depend on these two x and y, right? So the functional's value can be varying like this, right? I think it should go
But
like
so it depends on whether we fix the radius or not. No?
you just fix.
We
Let us
are
say you
taking
just
it
fix.
as a variable.
Correct.
Like,
You just fix a value, and I think it will give me some kind of point. You can just check it out, right? So, but okay, that is not a deal here.
Sir,
What is the question about, sir?
Whether this function remain convex for what value of y? What is the boundary value of y? And okay, so when it will change, I'll tell you how to find it out. Let us say if you have this h as like this, suppose 2y. If that y is dependent, right? So now in this case, can you tell me for which values of y this function is not going to be convex?
-1.
Negative values of y it will not be convex.
Right. Correct.
Okay.
So if I have y equal to -1, then this will look like this thing, right? And it will give me one of the eigenvalues as negative or the determinant as negative. So if the determinant is negative, that means it's not a positive definite or positive semi-definite. So
okay,
this function is
sir, determinant can be 0 also, no? Because it is semi-definite. So
yeah. So why should we less than 0? So yeah. So you understand, right? How can I say that whether this is so this convexity is dependent on x and y when your Hessian matrix is dependent on x or y, right? Is that correct? So if it is 2x, in that case, what I can say again?
For x less than 0.
Less than 0, right?
Hessian
like
matrix won't be convex.
Right. But current question, our Hessian matrix is not
it is
independent of y, right?
It is independent, yeah.
So in that case, definitely it's for any values of x or any values of y, the function will remain convex because if you see the structure of the function, right, that it's already a convex figure, right? So it's there.
Sir, also like for this equation, when we give greater than or equal to constraint, then when we construct the graph, it cannot be a convex function, right?
Which one?
The above equation, x minus 2 whole square. Yeah, this one, if we give it as greater than 1 as the equation.
Greater than 1?
Yes, sir. This whole equation, like, or for example, x square plus y square greater than 1. If this is the equation and we have to find if it is a convex function or not. So that time, how do we know that it is a convex function or not? Like using graph, we can say that it is outside the circle, so it cannot.
No. Can you just again tell me what is the function you are saying?
X square plus y square.
X plus bracket square.
Greater than. Yeah.
Greater than 1.
Yes, sir.
What is this greater than 1?
Like there was this question where x square plus y square, like the equation of circles, sir, like greater than 1. The symbol, yeah. This there was this question in one of the previous year question paper: x square plus y square greater than 1.
Okay, so is that a question? X square plus y square greater than 1. Okay,
is this
in that case, what?
Function or not?
Okay, so in that case, what I have to do? I have to define a function like this, right? Just take it to this side, right?
Yeah. Okay.
Now you just find out whether this function is convex or not, right?
But
or for
sir,
what value?
When we are plotting a graph, the in Desmos, then we see that it forms a circle, but the boundary of it is outside the circle. The boundary of the values, it will come outside the circle. So when we make a straight line through the
Why you are
circle,
making a straight line?
I mean, in convex function from 2 points, we have to join it in such a way that it remains in the same boundary, right, sir? Like you can check this in the Desmos graph. Yeah. Actually, the answer was given as this is not a convex function.
Okay.
It is containing all the values except that circle x square plus y square equal to 1.
Yes.
This is going to be a, I think it's...
This is not a convex function is the answer.
Square.
Yes, it is not convex.
Y square.
Less than 1.
Less than
Less than 1 is convex. Less than 1 is
greater than 1.
Yes,
Yeah.
so
this is
now you
the-
take a point on opposite side of the circle, it will not be a convex. You take points on opposite side of the circle and join them. It will not be lying. So it is not a convex function. To take opposite points on opposite side of the circle and join them, the line will pass through that.
So okay. So maybe let me check. This is going to be a circle,
Then it is
right? And now x is greater than or equal to 1. The region outside this circle, right?
Yes, sir.
Yes.
And so if you take points on opposite side of the circle, then if you join them, the middle line will pass through the circle, which is not in the set. So it is not a convex.
Okay, yeah. So yeah, let's say this point and this point, maybe in the first and third quadrant. If I try
But sir, why are we taking points outside the? Okay,
no, this is
outside the circle.
This is outside the circle is the region now, right?
Acha, okay, greater than 1. Okay.
Because first of all, you have to find out.
Everything-
So this is my x square plus y square equal to 1, right? So the points on the circle, right? And if I say less than, then means all the points within the circle. Now this x square plus y square less than 1, it's going to be convex, right?
Convex.
It's a convex.
But when I say greater than 1, that means all the points which are
Points
outside the circle. Now if I try to find it out, so I think that case is going to be. So
Not
let's say now we are here already. Maybe I'll just try to. Okay. That what was our function again? Maybe I'll try to see that x minus 7 to the
whole square.
Whole square
plus
X plus 9.
y plus 9.
y plus 9
Whole square.
It's not going to be right. So I think
Where
we have
it
to
is?
do it in a 3D graph, I guess.
Not working.
Okay, or maybe it's going to be okay. I'll just try to now. X minus 7, right? So
X minus 7 whole square.
7 whole square plus
Y.
Square. Is it coming?
No.
No. Okay, I don't know. I think we have to just check for the 3D graph, I guess. Equal sign. Okay. We don't have the equal sign here, right?
Yes, sir. We don't have the equal sign.
So
F equals to.
So now, because we don't know the radius, right here, that point, okay, in that case, I knew that 1 is the radius, right? Now we were actually checking within that. Okay, fine, okay.
So my doubt is in such less than or equal to constraints are given, we cannot get it to the other side, right?
So yeah, you have to check, right, whether which is the region. Then you have to think about the region. So first of all, you have to talk about that x square plus y square equal to 1. What is that? See, what is easier for you is to find out the equality constraints, right? So when x square plus y square is greater than 1 is given to you, in that case, drop that greater than sign, make it to equal to. So then you will get a circle with radius 1. Now you have to check whether greater than 1 radius, the points will lie where, and right? Is that correct? In this
Yes,
case,
in that
this is
case, then it will become a
Yeah.
Hessian. Yeah, it will become a convex function.
right, and in this kind of case where the function is given as a it's a function of x and y, and no other things are given to you.
Is this doubt clarification section, or you will be discussing few topics today? Or?
No. So like now I have just almost completed all the. So I think the questions in the mock is already covered. The week 9 and
Last
10.
question answer
TKT
is
there.
option C, right?
Where?
Last question answer is option C, right? Any value of.
Any value, yeah. This is the correct answer. For any value of y which belongs to R, the function will remain convex.
Because our Hessian matrix is not dependent on y.
On x and y. Yeah.
on
So
X.
here in this case, y. Yeah.
Y.
But on the mock, there is a deadline.
Tomorrow.
Yes. Yeah.
Yes.
Yeah. You can solve it. It's okay. Maybe I'll ask them to share the solution to you.
Yeah, share some solution.
Yes, sir.
Tomorrow I'll ask them to solve. Okay. So one more thing is remaining is the KKT condition, right? From week 10. But I think whatever we have discussed, is it okay? Like the concepts which you have covered?
Yes, sir.
Okay. So now the last one is this KKT. So I'll just talk about from the tutorial, right? Maybe we'll see the question from here itself, and then we'll talk the question in the in this mock, right? After that, I'll be taking it will be like after this question and that question, it will be an open session. If anybody wants to stay, they can stay, or else you can come tomorrow. Is that okay?
Okay, sir.
Okay. So this is the question, right? So consider the following linear program. Minimize 3x1 plus x2, right? This is what? Minimize 3x1 plus x2 is what? What is it called?
Objective function.
Objective function, right?
Objective.
And subject to what are these?
Constraints.
Constraints. So these constraints, g1 of x and g2 of x, what kind of constraints are these? Equality or inequality?
Inequality.
Inequality constraints, right? So now the problem set. So any optimization problem can be written. What is the generalized form of it? Minimize z, which is right. It's a function of, or let's say z only. I'll say it's an objective function, and you will have constraints, and g of x will be the constraint. So it can be one or more, right? So gi of x greater than or equal to 0, right? For minimization. Sorry, less than or equal to 0. Equal to 0. These are what? These are called inequality constraint.
So if it was maximized, then it will be greater than, right? Equal.
Sorry. Actually, if the problem, okay, so if I'll tell you exactly, if the problem is of minimizing the z, right, and if you have the greater than or equal to constraint, what you have to do is you just have to convert them into
less than
or equal to. That is the basic condition, right? And if it is a maximization problem, you will have to that greater than or equal to 0. That constraint should be there. But I think for the syllabus of this MLF concerns, I think it's not that deeper, right? But that is the important thing. What else is there? It's j of, what are these called? Equality.
Equality constraint.
So what did you say about maximize?
So if the problem is of maximization, right? So if maximize z, in that case, your constraints, you will have to convert them into the greater than or equal to. In case of minimization, they should be less than or equal to, right? Okay. If it is not given, if the constraints are given in terms of less than or equal to, right? If the problem is of maximization, you will have to convert that into that required format.
Will you show that also, conversion?
Not required. It's not
Why?
in the.
Not in our syllabus.
Okay. Yeah, but okay. Let us say It's very simple. Let us say 2x1 plus 3x2 is greater than or equal to 0 in this case, minimization.
Minimization.
How do you change it to
multiply by -1 on both sides?
Acha, -1. -1 why?
Just you will just see, no? If I multiply -1, it will get reversed.
If 2 is greater than 0, then -2 is less than 0.
Yes, it will get reversed, right?
Okay.
It's very easy. See,
Okay.
if you in the number line, if you have 2, what will happen to -2?
-2 less than 0.
That is all. Simple, right?
Okay. Minus.
Okay.
Yeah.
Fine. So that's the basic, basic structure of any optimization problem. Okay. So, and GA can be 1, 2, let's say R, any constraints will be there. So here we have given the minimization problem with 3x1 plus x2 as like minimize this 3x1 plus x2 subject to these constraints x1 minus x2 plus 4 less than or equal to 0, minus 3x1 plus 2x2 plus 10 less than or equal to 0, and x1 x2 are greater than or equal to 0, right? So these are the two constraints, g1 of x and g2 of x. Both of them are inequality constraints. So what are the KKT conditions? These are the 4 KKT conditions. I think first 2 are very important by like solution purpose, right? So one is what called stationarity condition, right? Which is del f of x plus summation of I equal to 1 to n ui del g of x. What is g of x now?
Constraint.
Which one? Which one?
G of x. Right?
Inequality.
Inequality constraint.
They are
Inequality
constraints, right? And h of x are what? Equality constraints. So if I see this one, and if my problem is what I have the equality constraints?
No, sir.
No. So that means this term plus summation of j equal to 1 to m vj del h of x equal to 0. So that term will be useful, or will there be there? No, right? It will not be there.
No.
Only we have to consider about the first 2 terms. Del f of x. What is del f of x? It's a gradient of that function, objective function. Ui will be some u, some u1, u2, u3, right? Some unknowns, not constants. And what is complementary slackness condition? That is ui into gi should be equal to 0 for all I. What does that mean again?
For inequality constraints.
Inequality
Right.
constraint.
And suppose you have this g1x and g2x. How this equation will look like now? By looking at this, u1 into
x1
g1
minus x2 plus 4
equal to
plus
0 is equal to 0.
So okay, is equal to 0, and sorry, okay, that is one, and the second one u2 into
u2 minus 3x1 plus 2x2 plus 10
equal to 0, right? So that means you are just multiplying some unknowns, right? Or unknowns, or I can say, let's say constant, if you think, to this equation to make them what? Into equality constraints, right?
Yes,
right? In the complementary slackness, what are you doing? You're just multiplying with u1 and making it to the equality, right? Are you comfortable with that part? Why I'm just saying is to remember it. Otherwise, because these are like, it feels like very complex.
We are not using gradient here, right? We are only using the constraint equations.
No gradient, right? Gradient is here only, right? The stationarity condition.
Yeah, as in the first stationarity equation only, the equation would just be 3x plus 2y plus u1 into that constraint, right? We are not forming any gradient.
Actually, you see, this can become actually, you can make them a separate statements also, right? Or you can convert it into the matrix. If you wanted to make it into the matrix, then it will become a so what will be the gradient matrix here? Del f of x. it will be vector, right? Okay, what is a vector?
3 and
3, 1,
1.
right?
Yeah.
3, 1. Is that correct? So del f of x will be here. Okay, maybe I'll just write it down. Okay, what is f objective function here? Let us say this one, right? So my
3x1 plus x2.
minimize 3x1 plus x2. I'm just calling it as f. Now the constants are
x1 minus x2
x1
plus
minus
4
x2 plus 4 less than equal to 0. Then
minus 3x1
minus 3x1 plus
2x2 2x2
2x2 plus 10. Okay, 2x2 plus 10 is less than equal to 0. I'm just saying that it is g1 of x and this is g2 of x. The first condition, which is called as a stationarity condition, all right? So stationarity condition, what it says? Del f of x plus u or summation of right? Oh, sorry, not d of del, right? And plus summation of t equal to 1 to, let's say, x or r or something, bj hi. But that is not it's not needed here, so I'm just
delta h1
delta h1 delta hi, sorry, right? And hj possibly, and equal to 0. So with respect to this, right, I can actually create a matrix, right? So or vector form. So it can be del of f of x, it can be 3, 1 plus what it will be now. So this will, can I just have that u transpose del g of x? Is that okay?
Yes,
how it
sir.
will look like now? U will be
U1 U2
u1 u2 of
one minus 1.
what it will be now?
1 minus 1 into u. Sir, u1 into 1 minus 1.
1 minus 1 and now?
u2 into minus 3 2.
Is that correct now? This is fine. So this summation, this entire thing will be like this. Are you able to see this part?
Yes, sir.
Right? You can do this, or you can just separately write like this. 3 plus u1 into, sorry, u1 plus
into 1.
Sorry,
1 u1 into 1 minus 1.
Minus
Yes,
u2, right?
okay.
Minus u2 equal to 0 and
So minus 3 u2. It will be minus 3 u2.
No, minus u2.
this multiplication.
Because
Multiply.
U2 is the constant for the second inequality condition. U2 is the constant for the second inequality.
Yeah. So but then why we are doing this?
The matrix is wrong, I think. The matrix is wrong. It should be minus 3 below and minus 1 above there.
Yeah, but
So 1 minus 1 should be there in the second row. I mean, yeah.
Shall I do?
Instead of minus 3, minus 1 will be.
Yeah, okay, but maybe is it this one? This is how it will look like now if I have this one. This will not be, right? Yeah.
No difference.
Okay, fine. Okay, I think I'm just doing some mistake there. Okay, it's okay. So, okay, this is not required anyway, but just I'm just showing you that is it's minus 1, right? Okay. This is minus 3 u2 equal to 0 and 1 plus again this one. Okay, then this will be minus
1 minus
2 u2 equal to 0.
Equal to 0.
So basically what you are doing is you are just taking this, right, 3 plus, because this is u1 times this one and this is u2 times this one, and you are just, when you are talking about x1, you will be just taking the coefficient of, or maybe the differentiation of x1 and x1 here, right? That's why you are getting 3 plus u1 minus 3 u2. Is that okay? Or
Yes,
if you look at if you are not, so okay, maybe this is not there. Just look at this part, how it will be looking like.
So directly do the partial differentiation.
Yeah, del f by del x1 plus u1 into del, what is it?
Actually, sir, we
What's
should
H1?
write the whole function
U2
and then
into U2 into del G2 of X.
X1 right now.
Not X1, X, sir. X.
When I
X is X1, X2. X is X1, X2, sir. X is equal to X. X is equal to X1, X2.
No, like this, right? So when I wanted to write it separately, how it will be? Is that correct now?
It will be X, differentiate with respect to X, and X
1, right?
will
X1,
be
X1. See, then only I'll get this right.
First differentiation will be with respect to x1, then the second
The
one
second will be with respect to x2.
x2, and last one will be with respect to lambda or u1.
That is Lagrange multiplier, right? So that is
yes,
also
sir. You are right, sir.
right?
Lagrange multiplier. Yeah.
So this equation, I'm just breaking it down into 2, and that will be del f upon del x2
Del X2 plus U1 into del G1 by del X2.
Del
G1 by
del x2
del X2 plus U2 into del G2 by del X2.
Right. So and if I follow this, I'll get what now? So for
same thing, sir. So 3 plus U1.
So del f by del x1 is 3 plus U1 times 1
minus
1
minus 3 U2
minus 3 U2 equal to 0, and here x2, right? So it is 1 plus minus
U1 plus 2
U2 equal to 0, right? These are the two equations, right? And these are the two equations I'm also getting here. Is that correct?
Yes, sir.
That is what my stationary. Why I'm just focusing on this is because this might be very useful, right? So the question will be there on this stationary, finding out the stationarity condition, complementary those conditions, right? So you'll have to know what is the complementary slackness. This is the easiest one, right? It is just like Uy into Gi equal to 0. What does that mean?
Or inequality controls.
So it will be like converting. So complementary slackness, and that condition will be U1 times the constraint, first constraint.
X1 minus X2, X1 minus X2
plus 4. And if I multiply with U1, that will convert into equality constraint, right? And the second one is x2 U2 into minus 3x1
minus 3x1 plus 2x2 plus 10.
2x2 plus 10 equal to 0. So you will have this equation 1, this equation 2, this equation 3, and this is equation 4, right? All those 4 equations you can see here. What is primal feasibility condition? All the constraints should be less than
equality constraint should be less than.
So for our case, it's already been there, right? Okay.
Yes,
and
sir.
what is dual feasibility? All ui's should be greater than equal to 0.
Greater than equal to 0.
Okay.
So in the formula, what is the HIs?
HI is equality constraint.
Equality constraint.
So
Okay.
in this question, it is not there, right?
Okay, sir.
Fine. Okay. So that's why.
Sir, so the primary solution will just be by solving x1 and x2 values, right? So, I mean,
primary
the
feasibility you are saying, or complementary slackness?
No. Just the x1. If they just ask you to find the primal solution x star, x1 star, x2 star,
Hmm.
does that mean we just have to solve the two equations and get
This
x1, x2?
4 equations to get x1.
Sir, even if we find u1 and u2, if we see in the third and fourth equation, u1 just can be taken to the other side 0. So it is simply meaning that we are just solving that.
Correct. So but then let's say x1 minus x2 plus 4. This gives me x1 as x2 minus 4, right? Is okay from equation 3. What is happening to equation 4? Again, you are saying that this u2 will go there, and you're just getting
yes.
for x1 and x2, right?
Yes.
But okay, again, in this case, I think that u1 and u2 is not going to be helpful, right? I think.
Actually, in any equation, if we see, when we use complementary slack condition, u1 and u2 will go to the other side.
Okay, but whether this u1 and u2 will be useful anywhere else? But I think this is okay. U1 and u2 will be with the.
If primal feasibility conditions are not equal, if primal feasibility conditions are less than 0, then u1, u2 will be 0. u1 will be 0. If primal feasibility conditions are less than 0, then u1 will be 0. But in this case, u1, u2 are not 0. So primal feasibility conditions are 0. So either of the two have to be 0.
Maybe we'll try to solve the problem here, right? So see, I think this problem can be directly solved by using the this one LPP problem, right? Just by drawing the constraints, and you will get the minimum value, right? I think this will not give me the minimum value, right? Is it true or no?
Yes, sir. It gives the minimum value.
Okay, so let us. If I try to solve it from linear programming problem, or maybe by drawing. So let us say what I have to do now. I have to draw these two on the graphs, right? So how many axes will be there in that graph?
2 axes.
Right, so let us say which one?
x1, x2.
x2. And what are this? x1 minus x2 plus 4. So what does that mean? x1 minus x2 plus 4 equal to 0. I have to make it equal to, so basically it is less than or equal to 0, right? So how will you draw this? x2 equal to, so I'll just make it, okay.
So intercept, draw the intercept, sir. If x1 equal to 0, then x2 equal to 4.
So if, so here I can just started with this x1 plus 4. So when x1 is 0,
then x2 equal to 4.
And when x1 is
x2 is 0, then x1 is minus 4.
Minus 4, right? So let us say here. So this line will be like this.
Join the 2 points. And less than 0 means below that.
x1 plus, sorry, this is x1.
x1 plus x2.
Or x1 minus x2 plus 4 equal to 0. This is the equality line. And when I say that
less than 0 means below that.
So which portion? The
below
portion,
that.
right? Okay. So, okay, we'll just talk about that, maybe those lines later. We'll just try to draw the another constraint, which is minus 3x1 plus 2x2 plus 10, right? So it is minus 3x1 plus x2 plus 10 is 11. Is it correct? 2x2. So that means 2x2 will be equal, is less than or equal to, is it 3x1 minus 10? That means x2 is less than equal to 3 by 2x1 minus 5. Is that correct? So basically, I have to find out this line. x2 is 3x1 by 2 minus 5. So when x1 is 0, what is the value of x2?
x2 is minus 5. Minus 5.
Minus 5.
So somewhere here, right? So this is minus 4, minus 5.
Hey, below, sir. Lower line.
This is minus 4. Yeah. x2 value, right? Sorry.
Yes,
x2 will be somewhere. Okay, let us say somewhere here, right? Minus 5. This is x2 when x1 is 0. And what is when x1 is sorry, when x2 is 0, what is the value of
X1 is
5?
10 by 3.
10 by 3.
10 by 3.
10 by 3 is
3.33.
around 3.33. So suppose if I just say this is 4, so somewhere here, right?
Yes, sir.
Let us say this is not accurate, but yeah, maybe the line will be like this, right?
Join them.
Will that cut to this line?
Yes.
Some
Point it will cut.
Right, so because the slopes are like this. Okay, so now the constraints are the first constraint is so 2x or maybe this line, right? So this, what is this line? Basically, this line is okay. Let's write down the equation of the line. This is minus 3x1 plus 2x2 plus 10, right? And this line was, this was x1 plus
minus
x2 plus 4. Now when I say it is less than or equal to 0 for blue line, or that the region will be this one, right? Is that correct?
Yes. Yes, sir.
And for red one? This will
Below
be
that.
right, okay. Now that
And
means
X1 and X2 are positive also.
yeah, and x1 and x2 are positive. That means what is the intersection region in that case?
Below
So
that
the region will be
This V shape. I mean
this one.
Yes, sir.
Okay, so now in this case, what will be the corner points which I should look for?
One is
This one?
then this one. Yes,
4
sir.
and the intersection point.
And this intersection point. So how I will get the intersection point?
By solving these two equations.
Yes. So one equation is what? x1 minus x2 plus 4 equal to 0, and the other one is minus 3x1 plus 2x2 plus 10 equal to 0. Is that correct? Okay, now or maybe I can just do it like this, and I say it's equal to minus 4 equal to minus 10 now. So I'll just multiply the first equation with 3. This will become 3x2. This will become
2, sir. 2, sir.
Why?
Okay, you multiply with 3. Okay. 3 is also fine.
Okay, so I think you were looking for x2, right? So I'm just looking for x2.
Okay.
So here, if I add it, what I'll get? Minus x2 equal to minus 22. That means
x2 is
x2 equal to 22, right? And here, and the other one will be then, I just have to plug into any one of the equations. So I'm just plugging into the second equation, right? So in that case, minus 3x1 plus 2 times 22 equal to minus 10, which means 3x1 equals to 44 plus 10, which is 54, right? So x1 will be equal to 54 by 3, which is 18. So x1 equals to 18. So if you can just see that, so this point is 22, right? This point will be 40, right? And I think these are the only 2 points.
10 by 3, 0, sir.
Yeah, sorry. Okay, it's like, yeah, thanks. It is 10 by 3, 0. Okay. Now, with the KKT conditions, the solution we have got, right? By solving for x1 and x2, the point which you have got is x1 equals to 18 and x2 equals to 22. And which point is that? So with this also, I got this same point, right? And that is fair only, right? Because both of them has to give me some common point. But whether this is going to be the minimum value or not, that's a that is the thing, right?
So how can we check this?
So okay, how to find the minimum value, right? So now I have got 2 points.
Objective function you have to draw.
Yeah. No, not required. So x1, x2 will be what? There are two values I got, 18, 22, and another one is
10 by 3, 0.
Okay, so now with this, so how to find which is the minimum value, right? So I think, see, you know that, right? These are the two corner points where I can get the minimum value, right? These are the potential points where I can get the minimum value, right? Because if you see the graph, now that graph will be going towards this side, right? So these are the points I feel that I should get the minimum values. So what is the function value at 18, 22? How to find out what is the objective function? Now in this case, I need the objective function, that is 3x1
3x1 plus x2.
So 3 times 18 plus 22. So what is the value here? 54 plus 22. I think it is
76. 76.
And with f equal to 10 by 3, 0, it is
3 into 10 by 3.
10.
So which is 10. So the minimum value of the function occurs at 10 by 3, 0, but with the KKT conditions, it is occurring at
1822.
Yeah, so at 1822, which is 76. But if it is asked to you to find out what is the minimum value of the function, right? You have to follow this method. What you have to do here, you understand, right? You have to find out the constraints, right? Is that correct? And then so you have to draw all the both the constraints over there, and you have to find out the value from there. But if it is asked to find out the value, objective value, the minimum value of the objective function using the KKT condition, which will be the correct answer then? This one, right?
Okay.
But it is not giving the minimum value, sir.
So with the KKT conditions, it is giving like this, right? You see the procedure, right? With this procedure, see these conditions follow this method, right? And with that method, it is giving me the minimum value, right? But it is not the absolute minimum there, right?
So can we use a Lagrangian?
Lagrangian multipliers also you can use.
Lambda 1, lambda 2, all that.
Lambda 1 and lambda 2, yes. Maybe the Lagrangian multiplier. Again, I think that's
U1, U2 are Lagrangian multipliers only, no, sir?
Yeah, but I think, yeah. Okay, so there is one. I think there is for Lagrangian multiplier, you have one more condition, right? You have to add there, or is it the same one? I have to check once. Just give me a minute. Lagrangian multiplier, have you used previously also somewhere?
So actually, I solved this mock question using Lagrangian multiplier. In that I took four.
Huh?
In that I took 4 lambdas, lambda 1 to lambda 4, and then I tried to take the function fx1 x2, which is x1 minus 4 whole square plus x2 minus 4 whole square plus lambda 1 times the constraints, constraint 1, plus lambda 2 times the constraint 2, minus lambda 3 times the x1 and lambda 4 times x1.
That's correct.
Something that, yeah.
Okay, so yeah, maybe I'll solve that problem also with the constraint. First of all, we'll try to see this this question, right? So have you solved the problem, and what was your answer for x1 and x2?
For 10, question 10.
Yes. 11. Or okay, 10, 11, 12, whatever. Yes.
Yeah, minimum value was 16.
16 and x1, x2
are? X1 is 4.8, I think, something. Actually, I have a doubt in 11 and 12. So.
Okay, fine. So if I wanted to solve it using the KKT condition, how it will be? Now, what will be your...
Sir, in the graph approach, how can we know that what is a corner point? I didn't get that one.
Okay, maybe let us solve this one with the graph. Okay. So yes, I just draw the graphs. Okay. So for the constants, so it is 2x1 plus 3x2, which is greater than 6, greater than equal to 6, right? And what is the second one? It's 12x1 plus minus 3x1 minus 2x2. Okay, these two are the conditions, right?
Just
These
12
two are the...
x1.
Sorry?
Just it will be just 12, not 12x1.
12 minus 3x1 minus 2x2.
Correct.
Remove x1.
So you have written 12x1.
Remove x1 from 12.
X1 will not be there.
Oh, okay, just 12. Okay, sorry. Yeah, okay. Okay. So whether these are the correct constants or I have to change it? This is a minimization problem.
Yes, yes, sir. You have
Equalities.
You have to change them, reverse them.
Right? All of you are okay with that part when I said initially.
Okay.
Right. So now they are greater than or equal to constants, right? I have to make, for minimization problem, what I have to do? I have to make them. So can I do like this? Minus 2x1 minus 3x2 should be less than or equal to minus 6. And then 12. Sorry, minus 12.
Minus 12 plus 3x1.
Right?
Okay.
And here x1, x2, they should be greater than or equal to 0, right?
So
now,
what are these indicating x1, x2? I mean,
so that means the solution you will find out only in the first quadrant, right? So if you see this graph, this is going here also, right?
Okay.
Or maybe here. We are not going to include this point. Why? Because x1 and x2 are both greater than 0. So that's why we just include this point, right?
Okay.
Okay. So what is this? Okay. Now I have to draw a graph for this, suppose. So what should I have to do? So for the first function, right? For the first equation, let us say it is 2x. I will just, because we are going to draw it for x1, x2, right? Okay, that I'll do later. So that means I'll just consider this as standard equal to minus 6. So I'll try to, get a function in terms of x2, right? So what I'll get now? I'll get maybe 3x2 is greater than or equal to minus 2x1 plus 6.
So can I just show the previous equation? How did you get minus 6 there?
This was the equation, right?
Okay. So you took it on the left-hand side and then did you change the sides?
No, I have multiplied entire equation with minus 1, right?
Okay.
So this will become minus 2x1 minus 3x2 and this will become minus 6. And when I just multiply with minus 1, this greater than or equal to become less than or equal to, right?
Okay, sir. Got it.
And similarly, I did for the second one also. Okay. Now from there, we have reached to this point, right? So x2 is greater than or equal to minus 2 by 3 x1 plus 2. Is that correct?
Yes.
Yes, sir.
So, okay. So I'll just keep it as like, let's say equation 1. Let's talk about the second one. What is it? Minus 12 plus 3x1 plus 2x2 less than or equal to 0, right? The thing is, okay. So minus 12 plus 3x1 plus 2x2 is less than or equal to 0. Now what should I have to do? 2x2 is less than or equal to, is it plus or minus? Plus. Yeah. 2x2 is less than or equal to
minus 3x1
plus
12.
All of this will go to right hand side, and then x2 will become less than or equal to 3
minus 3
by 2 x1 plus 6, equation 2.
6.
Now consider these two in terms of equality constraints. then this will become a line, right? So x2 will become 2 by 3 minus 2 by 3 x1 plus 2. And here x2 will become what? Minus 3 by 2 x1 plus 6. Now I have to draw these two lines. Okay. Okay. So okay, I'll just write it down here. X2 equal to, so first equation gives me this. 2 minus 2 by 3 x1 plus 2. The second gives me x2 equal to minus 3 by 2 x1 plus 6, right? Now can I draw this on this graph? So okay, sorry. Arey yaar. My lines.
Yeah, straight lines.
Okay, sorry. Okay, so this x2 is equals to minus 2 by 3 x1 plus x2. So this is x1, and let us say this is x2. When x1 is equals to 0, right?
x2 equal to 2.
Value of x2, 2. Let us say 2 is here, positive 2. Right? When x2 is equals to 0, what is the value of x1?
2 by 1 by 3, 1 by 3.
Plus 1 by 3. Right? So 1 by 3 will be, suppose, very close here, right? Is that correct? And the line will be passing through these 2 points. Is that correct?
Yes.
Just a minute, I'll just have to adjust a little bit. Okay, I think that's okay, right? Okay. And what about the second? And what about the second
It will be
equation?
1 by 3 or 3.
Okay, I'll just write it down. 0 equal to minus 2 by 3 x1 plus 2. So minus 2 by 3 x1 equals to
minus 2.
Minus 2, right? And then this 2 and 2
3, sir, 3.
So it will be positive. So x1 equal to 3, right? So x1 equal to 3.
And the other cases, you took it as x1 as 1, no, sir?
X1 as 0, right? So, okay, how to find out the lines is like, first of all, try to find out the intercept on x1 and x2, right? So to find out so what is the equation of line? This x1? Equation of line x1, axis x1. It is x2 equal to 0,
x2
right?
is equal to 0.
So when I do x2 equal to 0, I'll get the intercept on x1, right? And what is the equation of this axis x2? It is x1 equal to 0. And that is why we put these two values to get the intercepts on x1 and x2. So when I put x1 equal to 0, what I get?
3.
The intercept of x2, which is 2.
2.
Right? And 2 will be, let's say, marked here. And when I put x2 equal to 0, I'll get the value as 3. Okay. So now this is the, and the line passing through these 2 points will be your line, right? So I'll just mark it here. Okay. Fine. So what is the equation of this line now?
x2 equal to 2 by 3 x minus 2 by 3 x1 plus 2.
Okay, so okay, we'll write it down. Maybe x2 equal to
minus 2 by 3 x1 plus 2.
x2 equal to minus 2 by 3 x1 plus 2. Okay. What about this second line? x1 equal to 0. What is the
x2 equal to 6. x2 equal to 6.
Right. And when x1 equal to 0, then
4. I think.
So x2, then x2 equal to 0, right? So 6 minus 6 will be there. Well, 4, right? So 4 will be somewhere here. Now the line passing through it. Right? Okay. And when I say, so I can just sense that this line, right, the red one, x2 equal to whatever the line is there, is that that line is redundant, right? Or I don't know. Okay.
Which line, sir?
I have to check. Okay, okay. First of all, we have to find out, right? So okay, that is okay. So the red one means which, this one, right?
This black one, black line.
One, black line, because this is the equation of this line, and the blue line is blue, right? Okay. First place, that x2, this we don't have x2 equal to minus 2 by 3 x1 plus 2, right? What we have?
Greater than.
x2 is greater than this.
So above portion.
So which portion will be there?
Above portion.
Right? This is a feasible, or this is the region we are looking for, right? For blue line, what is it? It is not equal to, right?
Less
than.
x2 is less than or equal to. So which portion?
Below portion. Below portion.
Right? This one. Correct?
And x1, x2 positive.
And we have x1 and x2 as greater than or equal to 0. So can you just tell me which is the common region now here?
That quadrilateral region.
This portion?
This one.
Right? So, and if I draw it properly, so this, right? This one up to 3, then this and the blue line, right? Is this a region which is our feasible region, right? Where
Yes,
I can actually look at for. So what are the corner points over here?
3, 0.
This one?
4, 0.
0, 6.
Achha, 0, 6.
Here?
0, 2.
0, 2. Here?
3, 0.
4, 0.
3, 0.
4, 0.
4, 0. Any other point? Shall I look at for this point?
No.
No. Why? Because the constraints are x1 and x2 should be greater than or equal to 0. So that means I shouldn't be looking for those points. So now our solution, right? The optimal solution lies within these 4 points. Is that correct?
But our objective function is quadratic, sir.
That is okay, right? The constraints are linear, right? So constraints are linear, right? So I don't. Do you think it will make any problem there?
It could be any point in this. What do you say?
Yeah, out of these 4 points. So how will you check that whether this function will have a minimum value or not?
You'll plug all the 4 points in the equation.
So you just in this function, what is the function? F is equal to x1 minus 4 whole square plus x2 minus 4 whole square. What I have to do? So I have to put all these points at 0, 6, 0, 2, 4, 0, and 3, 0. And I have to check what is the value of function and which points gives me the. So I think we can just like directly find it out, right? With 0, 6, that means x2 is 0. Sorry, x1 is 0. That means this first part is 0. So I'll get 6 minus 4.
Second part is 0, sir.
4. No, it's for 0, 6.
The second part is 0.
Why?
No. Right. Both are non-zero, sir. So 0 and 6. So 4 square plus 2 square.
So 4 square is 16 plus 2 square is
20.
So 20 I'll get when? For 0, 6. For 0, 2. 4 plus?
Again 20.
2 square plus 2 square.
4 plus 4, right?
Yes, 4 square plus 2 square.
No. 0 minus, okay, 16 plus, okay, 4, 20, right? Okay.
20, same.
And here, with the 4, 0?
16.
4 minus 4 is 0. 16. Okay.
16.
This is for 4 0 and for 3 0.
17. 1 square plus 4 square 17.
17.
So which point gives me the minimum value?
4
0.
So minimum value. Okay. Now we'll check with the KKT conditions, right? So what are the stationarity condition there? What is stationarity condition? Del f of x, right? Plus summation of
I equal to 1 to n. Ui into
del gi.
I will just remove that h because that is this inequality. My function is x minus 4 whole square plus y minus
x1 minus x2, x1 minus 4 whole square plus y1, x2, x2.
Okay, so del and okay.
2 into x1 minus 4.
I'll just sorry. Can you just tell me what are these constraints? This one, right? Minus. Okay, maybe I'll just copy from here itself. Okay, right? What I have to do now here?
Differentiate.
Okay, so I'll do first one, del f1 upon del x1 plus u1 del. So this is g1 of x. This is g2 f. So del g1 of del x1 plus u2 into del
g2
of del x1 equal to 0. So with that, what I'll get now here?
2 into x1 minus 4.
2 into x1 minus 4
plus u1 into minus 2.
So can I say that minus 2 u1?
Yes.
Yes,
here
sir.
plus
3 u2.
3 u2 equal to 0. Is that correct?
Yes, sir.
Yes, sir.
So maybe I'll expand it a little bit. So 2x1 minus 8 minus 2u1 plus 3u2 equal to 0. Right. What will be the second equation? So this is maybe equation 1. Equation 2 will be del f by del x2 plus u1 into del g1 of del x2 u2 into del g2 of. So you understand, right? First place you have to differentiate with respect to x1. The second equation is by differentiating with respect to x2, right?
So,
and what is this? 2 times
x2 minus 4.
4 plus u1 into
3 minus 3.
Minus 3 of. So that means I can say that is minus 3u1 and
2u2
plus 2u2 plus 2u2 equal to 0. If I again expand it, 2x2 minus, let's say 3u1.
2x2 minus 8.
Yeah, I'm just doing it. Is that correct?
Yes, sir.
So what are the stationary conditions? Stationarity conditions? Right?
Yes, sir.
What is complementary slackness?
u1 into first inequality condition.
First inequality condition.
u1 into minus
2x1 minus 3x2 minus 6
plus 6, right?
Equal to 0.
Plus 6, right?
Yes, plus 6 plus 6.
Okay.
Plus 6 equal to 6.
And the second one is u2 into
my 3x1 plus 2x2 minus 12.
Yeah.
This is equation 3, this is equation 4. These are the complementary slackness. What are the feasibility conditions? these two, right? Primary feasibility.
G1 and G2 should be less than or equal to 0.
Right. Okay. And what is dual feasibility?
U1, U2 greater than equal to 0.
Sorry,
U1, U2.
That is dual, right? Yeah. Okay. So now what I'll get now here from here, equation 3 and 4, I'll get x1, x2 in terms of like x1 in terms of x2 or x2 in terms of x1, right? If you look at this, or you can
There are
actually find out u1 and u2
unknowns,
also.
sir.
Huh?
There are 3 unknowns in this condition.
In this condition, then what I
In
have
the
to do?
first two conditions, we have 4 unknowns, I think. Yes, U1, U2, X1, X2.
So first one is u1, u2, x1. Second is x2, u1 and u2, right? Was not there here? Here also it was there, right?
No, there are only 2 unknowns here, sir.
Okay. Because it's a quadratic now, right? So in this case, how to solve this then?
It was a special.
Okay.
So graphically, you can see that because
no, but we have 4 equations, right? We have 4 equations and 4 unknowns, right? I think that's a solvable problem, right? No?
Okay. But
no, that's correct, right? No?
Yes, sir.
So I'll just put it down, right? 2x1 minus 2u1 plus 3u2 minus 8. This is equation 1. The second equation is 2x2 minus 3u1 plus 2u2 minus 8 equal to 0. Equation 1.
Maybe we can eliminate it.
What is the here? It's here minus 2 u1 x1 minus 3.
So it's a quadratic, right? U1 x1 is a quadratic term, right?
Why?
Two unknowns are there, no? Multiplied. 2 unknowns are getting multiplied. U1 x1.
Quadratic. We say to that quadratic. I'm not sure, miss. Like I don't know.
There are 2 unknowns, and we are multiplying them, so it is a quadratic term.
Okay, but I thought like only quadratic. I'll be like calling to the degree 2. Is it not like that?
It is degree 2, right, sir? 2 unknowns are there, and it is 3x1
okay.
u2.
Okay, okay.
3u2.
So, will you be able to do that or no? That's the question now. Are we able to find out the solution from there, or we're stuck there?
We have to, sir. We have to first see if u1 into minus 2x1 minus 3x2 plus 6 equal to 0. So either u1 is 0 or the second term is 0.
Correct.
So if u1 is 0, then that is how we have to do it. It's a very long process. Okay.
Yeah. So what? No, I'll just explain it. Maybe I'll.
Sir, one more thing. It will be 6u1 and 12u2 as well.
Where 6u1? Acha, okay.
Third and fourth equation.
Okay. So
graphically, it is much easier to do than doing this.
Correct. So that's why I showed you that part. So I think you guys have to practice with the graphical. But at least you for KKT conditions related, you should know the steps, right? At least you should know what is complementary slackness condition. You should know the Lagrange multipliers things and this one, right? What is it? Stationarity conditions and primal feasibility, dual feasibility. Those conditions will be there. Solving through KKT conditions, it will not be easy. So here, what I have to do now for the first case, or maybe here, equation 1. The solutions will be coming through what?
Sir, instead of
first, you have to consider u1 equal to 0. If u1 is not 0, then the second term is 0. So you get an equation for that minus 2x1 minus.
So okay, I'll ask them to share the solution, right? It will be a like very lengthy solution. So I'll ask them to share a solution with you. If you want, you can just go through it. Maybe I'll discuss that tomorrow.
I also done this question, but
with the different method, Lagrange's.
Lagrange and multiply lambda 1 and all that.
But with how long it will be?
But that is also the same
Longish.
steps are there. But what I did was I after complementary selectors, I solved for x1 and x2. Means I took two cases where x1
when you
equals
want, yeah,
and then I'm trying
yeah,
to
correct.
Sir, my doubt is if u1 is equal to 0, then we will make the other equation as minus 2x1 minus 3x2 plus 6 is equal to 0, right? Or is it? So what is the use of finding u1 and u2? We can once, even if we find, we can just multiply it. We can take it to the other side and just solve x1 and x2, right? How is it different if we solve u1 and u2?
So you are saying we don't know if you don't find out u1 and u2, you just you will go for equation 3 and 4. You're just going for equation 3 and 4, and from there you'll find out what is x1,
x2.
But you will not be able to find out the u1 u2, right? Anyway, that will not help in the optimal solution. Okay, so optimal solution it will not help, but you will need that values of u1 u2, right? Otherwise, I don't think you'll get that correct optimal.
Do we use it, sir? Like in questions also, only the x1 optimum solution is only asked, so we would just substitute x and y, right? Like x1 and x2 or x or y.
But you have seen the case while in the previous question, right? So here the minimum value of the objective function comes out to be how much? 76, right?
Yes.
And when we saw through this LPP method, what was the value? So 10, right?
So if they given the question, I'm telling that if they given the question using KKT
conditions, then we can just follow.
Solve. Yeah.
If it is asked for the minimum value of the function, then in that case you have to use this one, right? But I think this is the much easier process to follow, right? LPP.
Yes.
Using graph also we can solve KKT problem.
KKT, yeah, correct. Then you just have to draw a graph, right? But again, see how tough it will be to draw this graph.
You have to be exact in that graph.
Yes. Right. But okay, I'll share you the solution of that. Tomorrow I'll ask them to share the solution with all of you.
Yeah.
Okay. Maybe let's stick around for 10 more minutes. I think it was a longish session, but if you have any more doubts, you just ask me. Tomorrow we'll just go into straightforward with 11.
Excuse me.
Yeah.
Sir, this x1 star and x2 star, how we will do that?
These are the optimal values, right? So that is basically this one, right? So here in this case, what is the x1 x star? 4 and 0, right?
Sorry. Yeah, this one.
4 and 0 will be the value, right?
So sir, please make the PDF available in our calendar.
This one? Okay.
Yes, sir. After sir, grant access to it.
Sure. Yeah.
Yes.
I don't know whether this is useful. I have written it. Okay.
Yes, sir. Please share it.
Yeah, I'll share it. If you need, you can just.
4 will be for x1 star, sir.
4. Why it is optimal solution?
Because it is the most.
It's
minimum.
Giving the minimum value, right? In this case, if you look at it, among those 4 values, right? I think we got 4 values.
Yeah. 4 0 is given minimum.
Yeah.
So we don't have to find out x1 star again.
That is x1 star, no?
Okay, that is x1 star. Okay.
Sir, but it will differ, right?
It will differ when
they say, yeah.
So here if it is so this question is solve the following optimization problem using KKT conditions. I will provide you the solutions for that. Okay, I'll just ask them to share the solution with you. Maybe I'll so if I don't know if one of you will not be able to go through the portal, I'll just clip it to the tomorrow session itself, right? So the PDF. Yeah.
So x1 star and x2 star by doing KKT, sir, I got like 2.6, 2.15, 2.67, yeah. And minimal value, I got it as 4 point something.
2 point, I think it will not go, right? I don't know whether this point is going to be feasible. I am not sure. See, if you would have said 3 point something, right? I think, what is the value? 2 point?
Okay, it doesn't fall in that region.
It is on the blue line.
No,
it is on the blue line, sir. It is on the blue line.
Oh, sorry. Yeah, just tell me what is the value. I thought like 2 point something and 0. No, it's not 0, right? 2 point?
It's 28 by 13. That is 2.15, and 36 divided by 13. That is 2.77.
It is on the blue line, sir.
Somewhere.
It is on the blue
Okay,
line.
yeah, somewhere here, right?
Yes, sir.
I don't know where the exact position, but we can say
Y
that.
star is 2.77 and X star is 2.15.
Okay, so within that, right? So
But this
again,
KKT, this solving graphically, like you said, sir, the easiest. But then apparently 40 is not the minimal.
Yes, so the answers are differing. Even my answer is quite different. I've solved it somewhere.
okay, I will share you the so tomorrow maybe we'll check with the PDF. So I have a PDF of it, the solution PDF. I will we'll check it tomorrow. But at least you it's okay. It's not, see this problem, right? The objective function is different.
Yeah, the tutorial method. No, why can't we follow tutorial method simply? 3 and 4.
Can find out. Yeah, you can find out there from there. Again. But so okay, basically what I'll say is maybe I'll finally tell you tomorrow about which method you have to follow for which kind of question, right? Accordingly, you will have to put it there, so it will not have a confusion. Fine, we'll follow that. So it's okay. Again, I'm just telling you that however you are solving, right, we'll consider how you have reached to that solution. Don't worry about it. Fine.
Sir, even Lagrangian method will also give
Lagrangian is fine. Lagrangian is fine.
KKT.
Why I am just not keeping all these methods at now itself is like it will be the end of the right. So it's like it will be for all, it will be confusing. So which method which you have to follow, right? I will tell you the one final method tomorrow. Okay. Apart from that, week 9 and 10 is fine.
Yeah.
Yes, sir.
The stationarity conditions, all those QKT conditions, at least it's leave about the optimal solution. The conditions, you are okay with that, right?
Yes, there I have one doubt. The complementary slackness conditions, no? It is only mentioned for the inequality constraints. So there is nothing.
No, it will be only for inequality, because what we are doing here in complementary
for
slackness,
equality anyway,
Equal constraints are already equal, right? Or equal to 0,
yeah,
right? So
we are making it equal, right? Equal to 0. We are making the complementary slackness is you are taking that liberty to make that equation into equality constraints.
Okay.
Is that okay? I think that name suggests, right? It's like okay, fine, that's okay.
Understood.
So I think we'll tomorrow we'll just look about the questions and week 11 and 12, right?
Sir, that max of x and y and mean of x and y.
I'll solve tomorrow. Right?
Sir, there are like 2-3 doubts in previous year question paper. Will you take it now or tomorrow, sir?
So on what topic are those?
These are from previous weeks.
Okay.
So yeah,
no,
the
it's how much time? Like, can you tell me what are the topics so that
you just tell me the procedure, sir? I'll calculate.
Yeah. Fine, tell me then. Yeah, then I'll take it now itself. It's not a problem.
Yeah.
5 minutes I will take and we'll rest because it's already longest session. So yeah.
So can we leave?
Yeah, you can leave. Not an issue. Maybe I can just do this one.
So tomorrow 12 p.m.
12 o'clock. Yeah.
And you will give this x1 star, x2 star also.
Sure. I will share you the PDF and then I will tell you which method to follow. I think all of you will stick to the same thing.
40 is not a correct answer, right? For that x1 star, x2 star.
Because that it is not asked through QKT conditions, right? It is through graphical method, right? Okay.
Okay.
Sir, can I share the screen so that
you
can
sure. Yeah,
directly?
please.
Sir, please don't forget to send a PDF.
Yes, I'll do that.
It will be very helpful for last minute revision.
Yeah, sure.
Sir, here, so this is saying that find the value of A for which y1 and y2 are independent.
Correct.
So what I did was I found the y1, y2 distribution.
You have found a distribution. Yeah.
Yes. So what I did was you'll get an equation. I mean, covariance for independent variables will be equal to 0. So when we are finding the variance of y1, y2, we will get equations in the form of A. But
right.
I'm getting the answer as 43. The answer was given as 40.
I think that question, that the answer given to that question was wrong that time. I'm not sure about 43 answer also. But okay, maybe is it okay if I solve it like very?
Can I say something?
Yeah, you can solve it tomorrow and like discuss it, sir. It's fine.
No, now itself I'm just.
Okay, now
it will not take much time.
It's done by Anand sir on last Saturday, sir.
It's okay. I'll take it. Maybe she hasn't attended that session.
Can I say something for this question?
Yeah. Please tell me.
Sir, the answer actually is coming 2 for most of the people. I have also solved this question, and on Discourse also I have seen that everyone is getting 2 as the answer.
Yes, sir.
It's okay. I am not sure, right? So okay, I have. So that's, I know that there is some issue in that answer. Maybe is it okay if I'll just? That's why I'll just clarify that question. Right?
Yes.
Mu equal to 1 and 5, and what is sigma? Can you just tell me row wise?
Okay, sir.
Is my screen visible? Okay, maybe I'll just clear my screen. Yeah. Tell me the values.
Yeah, so the values are mu is 4, 5.
1, 5 or 4, 5? 4, 5.
4, 5.
Okay.
Sigma value is 16A, A 25. Yeah.
Right, and x is actually is this, right? So x is normal mu comma sigma, right? And x is basically a vector, right? Okay. And y is?
Y is 2x1 plus 2x2 plus 1.
2x1 plus?
2x2 plus 1.
Okay, this is y1. And y2 is?
Y2 is 3x1 minus 2x2 minus 2.
2x2 minus 2. Is that correct? Is this?
Yes.
Okay. So what is the and we have said that y1 and y2 are independent, right?
Yes.
Okay,
We have to find the value.
x1 and x2. Okay, y1 and y2 should be independent.
No, y1 and y2 are independent, and then find out the value of a, right?
Yes.
So that is the question. Okay. So what is the basically what is the distribution of y1? It is normal. Basically, okay, what is y1? It is A transpose X, right?
Yes.
So what is A here?
2, 2, x1, x2.
2, 2, that's it, right?
Yes.
Not 2, 2, 1 also, right? It's only 2, 2. Is that correct?
Only 2. Yes, sir. Yes.
Then the distribution will be like this: A transpose,
mu.
Mu, and A transpose sigma A. Is that correct?
Yes, sir.
Then it will be normal with A transpose mu is basically your 2, 2, and mu is 4, 5. So if I just directly solve this, is it okay? That's fine, right? So I think
yes, sir. Directly you can solve it.
So it is 8 plus 10. It is 18.
18. Yes.
Right. So it is it's normal 18. And what about this? It is maybe here 2, 2. Sigma is 16A, A 25, 2, 2. So basically, if you just calculate this 2 cross 2 is like 32 plus 2A, right? And
yes.
2A plus maybe I can just write it here as 50 plus 2A.
50 plus 2A, yes.
And this 2, 2.
2 and 2.
It will be 64 plus 4A plus 100 plus 4A, right? So it is 164 plus 8A. So it is 164 plus 8A, right? And what is B here? B is equal to 3 minus 2. Is that correct?
What is B here, sir?
So let us say y2 is 3x1 minus 2x2 minus 2. The combination of x1, x2, likewise, A was 2, 2.
Okay, for
And B is,
Y2. Okay. Yes.
for
sir,
that I
got
have
it.
to find, right? So
Hmm.
y2 is 3 minus 2. Or else you can do, see, there is one more thing you can do is maybe you
Actually,
can
what I
do
did
that
was
y equal to bx. You can do that also, right? But
yes,
I don't know.
the complete matrix.
It's
2,
okay.
2,
Maybe
3.
I'll solve it this way.
Okay, sir.
The-
It will be
I
simpler.
think this will be not the problem, right?
Yes,
That
sir.
is
This.
the distribution for y1. What is the distribution of y2? So y2 for mu is how much? 12 minus 10, which is 2, right?
Yes.
Basically, I'll just draw it. Y1 is this. Y2 is normal with 2, mean 2. And now I have to find out the sigma. So sigma will be what? B transpose, which is 3 minus 2, right?
Yes, sir.
What is sigma?
16A, A 25.
5, 3 minus 2, right? So basically, can I say that this is 48 minus 2A, 3A minus 50, 3 minus 2. This will be, oh, sorry, it will not be a, is 48 into 3 how much? 150 minus 6, 144. 144 minus 6A plus, sorry, minus 6A plus 100. So that will be 244 minus 12. Is that correct?
Yes, sir.
Minus 12. Okay, so these are the distributions of y1 and y2. And what I know is they are independent. So in that case, okay, but I think in that case, I should know that their joint distribution should be equal to the this one, right? But they are already normal, so I don't think we can be able to solve it like this, right?
Actually, we have to use the covariance
Yeah.
anti-diagonal elements.
B we have to do, right? Matrix method. Okay, what is the
Yes.
matrix then? No, I just tried it, so it's okay. What is the matrix here you have found out?
I found 2, 2, 3 minus 2. I wrote it.
Is y1, y2 can be written as
2, 2, 3 minus 2.
2, 2, 3 minus 2. Okay. So basically this is, okay, I think this is y equal to 2, 2, 3 minus 2 of x1, x2 plus
1 minus 2.
1 minus 2. Sorry, okay, that is okay, right? So I think this y is in terms of ax plus mu, right? That is the case, right?
Yes.
Okay, in that case, what will be my mean? Or what will be my distribution for y? Then it will be like we have the
into
property
mean
to
of
find
x, A into mean of x plus mu. B into mu, mean of x in plus
distribution is normal b into x plus c, right?
Mean of x.
Okay,
B
c
into mean of x. C is 1 minus 2,
constant.
right, sir?
So we have to add, right?
A constant. We don't need to do anything else.
B into mean of x is given, sir.
Mean of x is
Mean
how
of
much? It is
4,
5. So that means b is
B into mean of x.
okay. So it is 2, 2, 3 minus 2 and 4, 5, right?
Don't remember.
Okay, 4, 5. There it is. 4, 5.
4, 5.
And plus
Plus
also will
1
be
minus 2. 1 minus 2.
Have you taken this plus while solving this? This has to
But
be there.
mean is not asked, sir. Mean is not asked. It is covariance we have to find.
Right. No. Okay, that covariance time, I think it is not needed, right? Okay.
Yes, sir.
Okay, so basically it is 8 plus 5, 18 plus 1. Okay, 19 and 12 minus 10. 2 minus 2, 0, right? Okay, that's correct. What about, okay, I think this, basically you will get a covariance matrix also similar to that one, but okay, let us see. What is B? So the covariance matrix is, it is, I think, B sigma B transpose.
B transpose, yes, sir.
So it is
2, 2, 3 minus
2, 3 minus 2. Sigma is?
Sigma is given, sir.
What is it? 16
A 25 into its transpose into 2 this 2 3
2 minus 2. Okay. So maybe I'll solve this first. So it is okay, 32 plus 2a and what is it then?
48 minus 2a.
48 minus
in the second row, second column, sir.
48 minus 2a. Yeah. Here it is 2a plus 50.
50.
And what is it?
3a
minus 50.
Minus 50.
The final version will be, okay, it's complex. 64
plus 4a.
Plus 4a plus 4a, that is 8a plus 100 is 164 plus 8a. I think these two values will be there, right? On the diagonal side, 244 minus 12.
No, sir, it will be a 4 into 4 matrix, right, sir?
I have to, yeah, I have to write it down, the second value. So what is the second value here?
96 minus.
Okay, 96 minus 4a.
4a.
Plus
6a minus 100.
So the final is 196 plus.
It is starting.
Now this should be equal to 0, sir. 196 plus 2a should be equal to 0.
To 0, right, because covariance is 0 for independent.
Yeah. So if so y is a so yeah, covariance between, so if it is independent, that means this to be 0, right? So 196 plus 2a should be equal to 0, and that means 2a equal to minus 196, right? Is it correct? Are you sure these values are correct?
Some mistake is there, sir, I think.
First row, okay.
They are saying that answer is 2.
No, 1 minute. I think the 2 cross
196 minus, sir, 100. 96 it should be.
It should be, okay, I'll just solve.
I think it is 96 minus 100 plus
96
2a.
minus 4a plus 6a minus 100. So that means it is 2a.
2a minus 50, minus 96.
Minus 4.
2a.
Minus 4, yeah. Now it is tallying.
Yes, minus 4. Yes, sir.
And if this is the same, because this will also be a same, right? But is it coming out to be same? Is it checked? Have you checked it? So that should be, because it's a covariance matrix, right? It should be symmetric, and this will be like this into this, right?
Yes, sir. It is same. It is same.
It's 96 same, yes. Minus 4a plus 6a minus 100. Yeah, that's it. Now it's correct. Now
2a minus 4 will be equal to 0. So a
0.
Equal to 2.
So which gives me a equal to 2. A equal to 2 should be answer, correct answer. All okay? All good? Any issues?
Sir, is there any property like if y1 and y2 are independent, then the off-diagonal element should be 0?
Yes. The covariance has to be 0. That is a property. I think we have studied 3 properties, right? And the third one is what? If xi and xj are independent, then the covariance of that, right? So what does that mean is if y1 and y2 are independent of each other, then their covariance has to be 0, right? That is always be there. The property is there. Okay. So with that property, A equals to 2. That is the third property which we have seen, right?
Yes.
I'll again tomorrow I'll again revisit all those.
So the difference between the actual answer and the printed answer is very
See
big.
what happens is, right? So I think you guys are there for like longer time in this degree. So I think, see, whenever any question becomes wrong, your answer keys are with you, right? And that time the mistake will be there and it will stay there, right? It will not change. But while calculating the marks, the question, the answer will be adjusted, right?
Yes.
Yeah. So the marks might be given to the other students that time, that paper, right? During that paper. But because the answer keys are there for the longer time and you guys are referring to that same thing, the question, the answer is wrong written there, it will not change, definitely, right? But the correct answer has to be 2.
Okay, sir.
Okay. Any other?
There is another theory question.